Okay, here we are. You guys ready? Unit 10. So this is lighting systems, but it's a bit more than that. So for the lighting part, obviously we need to discuss the lighting. Enhance the vehicle safety by increasing the driver's visibility. Also used inside the vehicle, for example, to indicate messages to the driver or convenience to the occupants. So for example, enhance vehicle safety by increasing the driver's visibility, like headlights. Well aimed, correct brightness. Ideally, you know, something that can project far enough, right? All these details. If you've ever driven an old car, sometimes you can't really see that well. If it's a new car, you should be able to see really well. If it's a car that's been modified with like aftermarket headlights, sometimes you as the driver can see really, really well, but everyone else coming at you can see nothing at all, and they go off the road and crash. And that's, so we're kind of getting into those details. This one being used inside the vehicle to indicate messages such as the genie lamp. When you see the thing, it looks like a genie and you're waiting for your 3 wishes, and instead what you get is a seized engine because it was low oil pressure. These types of things, these lamps. And also convenience for the occupants. So let's just say they put down the visor and they flip open the little flap and they got some lighting for their vanity mirror or for the dome light or, you know, a reading light, etc. Map light, they may call it a map light too. Although I don't see people use maps anymore. But they got a backlit map on their phone or their infotainment, right? So that's the overall lighting system. The reason that we cover this specifically is this is actually an individual section on the ASE. It's just lighting systems. Right, and then from there, modern vehicles, maybe LED, which is my personal favorite. Xenon, anyone heard of xenon lighting? We also call it HID, high intensity discharge. Fun fact about this one, this runs at high voltage, so you actually have to know a little bit about this before you go testing it. If you test the wrong spot on this, you can actually be shocked. I wouldn't say full on electrocuted. It's high voltage, it can shock you. It's low amperage, so it can't like really hurt you, but you'll feel it. Oh, you'll feel it. And then, of course, on a newer car, it's using electronic body control. So like back in the day, the lights were controlled by the driver flipping switches and pressing buttons, right? But now, you still can flip switches and push buttons, but those are inputs to a control module, to a body control module, and then the body control module ultimately controls whether the lights come on, whether they stay on, whether they turn on when it's dark or turn on when it's light, or whether they turn off after 30 seconds from when you get out of the car to help you get inside the house or whatever, right? So it's new stuff is very, very control module driven. And then the xenon, so you know, xenon and HID. Xenon is the specific gas used in an HID. HID is just saying like a higher intensity. Cool. Yeah, they don't even have a filament. That's what's interesting. They actually have xenon gas in a chamber, and they'll have high enough electricity, high enough voltage going through there to ignite the gas. It's burning the gas.
What kind of lights? Those
HIDs.
No, the ones that like they make old bar signs.
Oh, kind of like neon. Yeah. And neon's cool. Neon's great. Love the colors in neon, but they're not really that good for projecting a distance. Same idea. Mm-hmm. So we need a couple extra parts on these HIDs and xenons. And the other thing that's slightly different, but part of this final unit is introduction to on-car testing and diagnosis in part 2. So we're going to do just a bit of that, and then this is going to be followed up with those videos like we were talking about regarding the simulator. Okay, so what that's going to look like, applying prior knowledge. So if we were to look at summary of the units 1 through 9, it's going to be things like just understanding how the electricity flows, right? The Ohm's law type of thing. Being able to look at a wiring diagram, being able to identify a connector and terminal, being able to trace a wiring diagram, being able to predict a voltage, and then using the DMM to go ahead and perform various voltage tests, right? So if you take all 9 of those units, if you could do all that, you should be able to, boom, roll straight into 10 and get your first chance of getting out on the car with an inoperative headlight, do various tests based on all these skills, and then say, yes, this vehicle has an open circuit between connector C100 terminal 2 and ground G2 or something, right? You should be able to give me a really specific diagnosis as to what's wrong with that. Make sense? So that's kind of where we're at. And then testing on the vehicle using back probing. Now I expanded on this a bit. You can do some front probing. You could do a number of different things, but back probing is generally going to be the most accepted. So right at the end, I want to show you the different back probing tools. And then the summary of that will be next week on the hands-on final. You'll be back probing and actually testing voltage. Cool. So this is what we're into now. I think it'll be a lot of fun. So let's talk about the different lamps. So an incandescent, you know what an incandescent is? That's the thing with the filament, right? So if you guys ever go into Home Depot and Lowe's and stuff, they have the old school Edison bulbs where you can like see right into them, and they have like a filament, and it looks antique and cool. That's your incandescent. If you ever hear the term incandescent, that just means it has that glowing filament. Halogen uses a filament, but a type of gas, halogen gas inside. And this is going to be better for like a headlight. We're going to make a lot more lumens. So the light measurement is lumens. That's going to be much better for illuminating in front of the driver, because remember, we want to give them good visibility. And then you got vacuum tube fluorescent. So to be really honest, we're not using this in cars that much. But if you look in a shop, you know, they have those glass tube lightings. They'll call them like, oh, that's a fluorescent. Kind of similar to the neon like we were talking about. Yeah, exactly. These above us are vacuum tube fluorescent. So they'll have actually a chamber, and it's literally vacuum inside. And that's why if you ever drop one and it kind of sounds like it explodes, it actually more like implodes, really. And so these are kind of special because you can't, for example, use like 12 volts to like light that, to light that gas, to illuminate. You can't use 12 volts, so we need to use a thing called a ballast. And the ballast is going to take, in theory, we'll say 12, but in reality, we're mostly using these in buildings. So we would take the 110 or 120 volt AC, and it would step it up to a much higher voltage. And the higher voltage, remember, if you remember voltage, it's electrical pressure. The higher voltage can actually jump the gap and actually arc and light these. And that's kind of similar when we get into this. So vacuum tube fluorescent, probably not going to see on a car. HID, xenon gas systems, you'll absolutely see on cars. This is pretty common.
Those are the ones in the new cars now?
They can be. On a new car with the nice white, really clean looking, well lit lights, it could be an HID or it could be an LED. And actually it's hard to say. To know, we'd have to really look at them. So if you look at this HID, everything I just said about the fluorescent, you need 12 volts coming in. It needs to go to almost similar to like a ballast. Sometimes they call it a ballast. And sometimes they'll call it different things. But if we call it a ballast, the ballast is going to take that 12 volts or let's say that it's running, because we did charging systems, right? Let's say it's running and you got 14 volts. It's going to take the 14 and it's going to turn into, you know, whatever number we need, 10,000. So you're going to get your 10,000 volts after that ballast, and that's what's going to go directly into the HID or the xenon bulb. So they're interesting, they're different. The way we test them is slightly different. And then you get LEDs. LEDs to me, I did say they're my favorite. They're also a little more simple. So with an LED, they can run no problem on 12 volts. We don't necessarily need to bump the voltage up because we're not trying to arc across the gas or anything. The LED is the solid state, LED being light emitting diode. The challenge with an LED is one light emitting diode doesn't make enough. So a lot of times we'll have like a chip with multiple LEDs. So, you know, there's a circuit and they're going to have, you know, dozens of LEDs to give you that intense illumination, to give you all the lumens that you want. The positive is these are really efficient. They don't use a lot of electricity. So one of the reasons I like them is, let's say you wanted to do like a light bar and headlights and these lights and those lights and those lights. If they were more standard, like incandescent, you'd have to run a whole bunch of big wires because your amps are going to go through the roof. But with an LED, because they're so efficient, you can get a lot of lumens with a little amps. So you could run like a normal smaller size wire. You don't have to have, you know, all the, let's say like some sort of junction box where you can have a whole bunch of lights tied in. You can pretty much just run like a normal size wire and do a whole bunch of LEDs. So I do like them, and they're also reliable, and they're fairly inexpensive. So compared to like an HID, if the ballast goes bad, they could be really expensive. Aftermarket, not so much, but OEM could be very expensive. Mm-hmm.
So the little box on them, that's the charging thing, or is that the what you're talking
Yeah, a lot of times we'll call it a ballast. Yeah, so that box that you're talking about, let's say it's aftermarket HIDs because they're the most easy to visualize. You take your factory connector, you undo it, you plug it into some box, right? Then that box comes with its own little connector and their own little wires, and that goes to the special bulb. When you plug in your original connector to that box is taking your 12 or 14 volts, and it's going to increase it to whatever the voltage needed for that particular light frequency. So like a 6K light is going to be like pure white. Then you can get into more of the blue, the purple, right? So that box takes your 12 or 14 volts and makes it into whatever it needs to be. And that box can fail. And when it fails, it needs to be replaced. And the aftermarket ones are not that expensive, but they're also not that long lasting. The OEM ones can be $500 for a new ballast. So you got a car that comes in with a headlight and op, you're kind of like, well, is it the bulb? Is it the ballast? It's too expensive to guess at that point. So you really need to do the diagnosis and be correct. And sometimes those ballasts are hard to get to as well. They're like mounted up to the headlight. When they're aftermarket, people leave them hanging, zip tie or whatever, you can get them. But if they're factory, they're going to be secured someplace that gets airflow to cool them.
Into the fenders, right?
Somewhere like that, sometimes on the bottom of the headlight, like somewhere. It's inconsistent, and they're not cheap, right? So, and then if we look, conventional incandescent bulbs, so that's the old school, are being replaced in many applications by these more efficient lights. Because if you really think about it, remember the thing driving our industry is fuel economy and emissions, right? Typically, it's government mandates, quite honestly. So if we want a vehicle that's going to have better MPG and lower emissions, we need to save gas. We need to burn less gas, right? If we want incandescent bulbs, those pull more amps, which now that we've done charging systems, you know the alternator's got to supply all the power needed for all the bulbs. So if you have a bunch of incandescents, your alternator's got to work harder to supply all the amps needed for all these incandescents. If you yank all the incandescents out and you put in a whole bunch of LEDs, your alternator's going to be like, oh, all of a sudden I don't really need to make that many amps. It's not going to excite as much. It's not going to field as much magnetic field, and it's actually going to make the engine work a little less hard. So you're going to get a boost in miles per gallon, and you're also getting a reduction in emissions, right? So the lighting has gone to the more efficient designs, not just because they're cooler, but because it actually saves fuel and lowers emissions, okay? All right, so there's your incandescent. This picture is just a bit hard to see, but you can see the filament in there. All right, so trick number one, if you think it's the bulb, so y'all know, you can actually remove the bulb and you can look at that filament. And if that filament's like this, and you can see that it's no longer touching, you know that bulb is blown bulb. So it happens as that filament glows, it gets red hot, right? And someday it's gonna fail, and when it does, it just goes poof, it just blows apart. Because it's kind of spring loaded, it's like really tight. So poof, if you see it and it looks blown, you can clearly see the open, it's done, the bulb is no good. Additionally, when it does blow, a lot of times it'll kind of like darken the glass right here. So if the glass looks kind of black, you're like, oh, it's got a blown bulb. No problem. These are simple. You know, I sometimes pick on my dad, like, and I mean it in the best way. It's just a really good example. He's old school. He grew up around cars like his whole life. He's an auto body guy. Auto body technicians, you don't see them bust out the fluke meter, the DMM and stuff. You know what I'm saying? They look, they feel, they see if it's straight. They could spray paint in ways that I can't even remotely dream of. So if he had a blown bulb, you know, my dad'd be looking at this, you know, like this, like looking like, oh, that bulb is blown. But this is the thing. If it's an LED, you can't do that. If it's a xenon bulb, you can't do that, right? The visual aspect really dies with the incandescent, so you know. But if it's an incandescent, by all means, look at it. The only thing is, I've seen in a few instances where you look at the filament and it seems fine, and it's actually still blown. So if you did want to, you could also check resistance on this bulb. You can literally put your meter on ohms and you can measure, the resistance of the filament. And if it reads OL, do you remember what OL kind of means? OL, an open. And if you measure it and it's open, the bulb is no good. Part of the reason that we go for the bulb is because it's fairly accessible. The manufacturer makes it easy to get at this bulb. So you're like, you know what? Rather than me trying to dig for the connectors and pull up the carpet and pull panels, like just pop the bulb out, look at the bulb. If it looks okay, you could still pop the bulb out and measure the resistance. There's some testing that we could do on the bulb. Cool. So this is a little bit old school. FYI, when we have the filament glowing, it can be 5,000 degrees. And as a result of the extreme heat, it glows white hot, and that's literally how the light occurs. So it's kind of interesting when we talk about electricity. We can do magnetism. We could, let's say, make heat. Right? To make this bulb glow, we're actually just making heat. It's just that the heat is so hot it glows white, and that's where we get the light. So if you think about it, it's not even really that efficient. I mean, we're just basically using it as a resistor to the point where the filament is so hot it's glowing white hot. How long you think that's going to last? I mean, that's going to fail. When? Hard to say. So if you do have a light out, the most common would be the bulb, because we're putting this thing through the ringer at 5,000 degrees for hours and hours and hundreds of hours potentially before the bulb fails. It's kind of impressive. Okay? Now, if you think about this, remember how that bulb is like a coil of wire, sort of? That's the load in the circuit, right? So coming into that coil of wire, we should have our 12 volts, our source voltage, and going out of it, we should have 0. It should drop our 12 volts going through that filament, and that's the reason that it makes the white hot, okay? And then if inside the bulb, if the bulb is sealed and everything is good, it generally shouldn't burn, or it shouldn't be smoking, or it shouldn't make that black mark, because inside the bulb, the oxygen's removed and it's replaced by inert gases. Inert simply meaning there's no oxygen, so that it will not literally combust. So when we have an engine and we go to start the engine, we're pulling in air, right? But really what we're trying to pull in is oxygen. If we pull in oxygen and we add fuel, it'll actually combust. In these bulbs, it's inert. Part of the reason that's so important is if you ever have a glass bulb and the glass is broken or cracked in any way, it's done. It's done because it needs to be sealed and have inert gas inside. It can't have air which has oxygen inside. That's a no-go. Okay, make sense? And you guys have seen, if you drop a bulb and it breaks the glass, it's done. It's over. Even though technically the filament might still be there, you're going to plug it in, it's going to go for a short period, and then it's going to actually burn. Right? And then sometimes the amount of power it uses can be marked on the lamp. So power is measured in watts. That's volts times amps. That's the formula for power. So if you want to know how many watts the bulb consumes, it's probably on there. So if you had a 60 watt bulb, that would be, you could do the math, 12 volts to get to 60 watts, probably gonna be like, let me think, 12 volts.
So you said volts times amps?
2 amps. Yeah, it's volts times amps, exactly. Yeah, that's a little bit, 5 amps, right around 5 amps. So it's volts times amps. In the car, we're gonna call it 12. But now you guys know, because we've been through charging systems and everything. 12.6 if the battery's charged, 13 point something, 14 maybe if the alternator is working, which means if the engine's running, right? So that number changes. But yeah, if you have a 60 watt bulb, and by the way, in a car it'd be more like a 4 watt, okay, but if you go to Home Depot to buy a bulb, let's just say, you look and there's a 60 watt, and then there's a 90 watt, and then there's a 120 watt. The 120 watt is going to use twice the power of the 60. So if you're trying to save electricity, you'd be like, oh, let me put the 60 in. That way I don't have such a big electric bill, huh? Makes sense? Yeah. But you know what the negative is? What do you think? Why would somebody go for the 120 watt? Brighter, exactly. So with these incandescent bulbs, it's not real complicated. The more power it consumes, the more light it's going to put out. Kind of makes sense? But that's only incandescent to incandescent. If you went with an incandescent compared to an LED, a lot of times the LED may say comparable to a 60 watt, but if you look, it actually may be more like 3 watts or 5 watts. And then you're like, wait a minute. So I'm going to have an electric bill for the 5 watt bulb, but I'm going to have the light of a 60 watt bulb, and boom, there you go. That's why LEDs have absolutely taken over. If you roll into the store to buy bulbs, they have tons and tons of LED choices and less standard bulbs. Make sense? Now, in a car, we could do the same thing. You could take out this incandescent and plug an LED in there, and the LED, a lot of times people like them because they give like a whiter, cleaner, more modern white light. So if that's in a tail light, your tail light would be kind of like dim red, but now with an LED, it's like a nice bright red. It looks more modern. So, you know, it's just a little bit different, and the LEDs will consume substantially less watts. If it consumes less watts, but we're still running the 12 volts, that means it's way less amps. So that's what I'm saying. LEDs don't consume a lot of amps. They're not drawing a lot of amps. It's very low amps. Kind of nice. Cool. Now about incandescents. They are inefficient, and that'd be an understatement. They're typically converting about 10% of the electricity used into the actual visible light. So if you think about that, if you were to throw $100 at this bulb, 10 of it is going to be productive and 90 of it's just going to be wasted through heat. The bulbs are hot. The heat's heating stuff that we don't need heated. We don't want heated. Makes sense? We're only really getting a 10% return on investment that's in the form of actual light. And then again, watts, voltage times current. Cool. Oh, and PS, this is a single filament. You guys will see a lot of these bulbs that have dual filaments. So there will be one filament and then another filament. That's common on taillights, turn signals. Let's just say it's a tail lamp that does tail lamps and stop lamps. You guys know if you're looking at a tail light, a set of tail lights, here you are behind the car, set of tail lights, because it just blew your doors in, and you're like, and it's just walking away, and you're like, oh, those tail lights are nice. First off, that's not good. You're not supposed to be looking at tail lights when you're trying to race. Not on the road. This is something that happened at the track, I think. You'd be looking at them. How do you know the brake lights have come on?
When they push the brakes.
Yeah, but how do you know they push the brakes?
It illuminates more.
Exactly. So one filament for the taillights will be more resistance and therefore less amps and therefore less bright. But then the second filament will be less resistance, more amps, more lumens, brighter. So we'll send voltage to the dim filament for the taillights. And then when you step on the brakes, we actually send voltage to the bright filament all in one bulb. So one bulb is taillights and brake lights, but one filament for taillight and a different filament for brake lights. Make sense? So if the filament for the brake light's blue, the filament inside that bulb for the taillights may still be good. So you may have a vehicle that the taillights are good, but the brake light doesn't work. It could still be that one bulb that does brake and tail.
Or the other way around.
Or the other way around. Exactly. Uh-huh. Or we could also sometimes have a taillight bulb that does taillights and turn signals. So you'll have a taillight that'll work, and then the turn signal part may not work. And so it just varies. But just be aware, one bulb can house two filaments. One filament can be bad and one filament can be good. You still need to replace the bulb though. Okay? And then here's your halogen. So again, there is a filament there. It's a little bit tough for you to see, but it's a type of incandescent. But inside the glass, it's filled with a halogen gas, like maybe bromine, iodine. They have a longer life expectancy. They're generally brighter. So like if we want them to be a lot brighter, where would we use this type of bulb? Headlights, yeah, exactly. And that is a headlight bulb or a fog light or high beam, low beam fog light, these types of bulbs. And then they're manufactured from highly heat resistant materials, and that's going to help them have a lot longer life. The headlights have kind of a hard job. They have to put out a lot of light. The taillights, not so much. It's a little easier. So we make these more heat resistant. We put the halogen type of gas in there, And that's part of the reason they're more expensive. So some of these bulbs are potentially $15, you know, for a bulb, whereas a taillight bulb may be $4. Okay. Now, what's this say here? The bulbs must be handled carefully as they're sensitive and can be damaged by even finger oil residue left by fingerprints.
Oil heats up more.
Hold up, what you guys don't have grease and oil on you're not lube techs. You might have never even done an oil change, and if you're going to go and change this bulb, you still have oil on your hands. That's your oil. Yeah, so the best way to handle these, I agree, a nice clean pair of like rubber, nitrile latex, some clean glove that's going to keep your oils inside your hands, which is kind of better for your hands anyway. Or if for whatever reason the gloves are unavailable, right here is acceptable. Holding it down here at the metal, that's okay too. But then when you start to try to put it in, your eyes are closed and you're blind and stuff. It just probably the gloves are a better idea.
Have you ever seen one pop?
Turn off the light.
Sure. Yeah. So I'll tell you, you can turn off the light, but even if the light's off, if you leave your fingerprints on there, it's going to shorten the life. So I'll summarize that by a story. In my summer class, we run usually like introduction to auto, kind of like the basic boot camp class. And the guy in the cafeteria needed a headlight replaced on his Tacoma. And he's a great guy. He doesn't actually even work for the school. He's an independent contractor. So I had one of the better students say, hey, go replace the bulb in Jimmy's Tacoma. He's got the bulb and everything. So this student went ahead and replaced the bulb. And then like a month later, Jimmy comes back, hey, that bulb is blown. You didn't replace the bulb? And I said, yeah, I replaced the bulb. And I had the student do it and everything was fine. He verified it worked. It was good. Well, then why is it already defective? And I thought, you know what? I probably didn't spend enough time explaining. If you handle this bulb and you leave fingerprints right here, it will absolutely decrease the life of the bulb. Okay? So on these, no touchy over here, it will decrease the life. And you'll see it smoking, it'll burn the oil off. It just makes it fail sooner, okay? So that's how we work on these. Different than an incandescent, and a typical incandescent, not as big of a thing. If it's a taillight bulb and you're not working with gloves, not that big of a deal. If it's a halogen like this, it's much more critical, no fingerprints, no oily residue. Make sense? So the next time we said, all right, we're gonna do gloves, let me be a part of this one, we'll fix it, we'll hook it up, and that bulb's still going. So right there I have a matter-of-fact experiment. Handled with oily fingerprints, 30 days it was blown. Not handled with oily fingerprints using clean gloves, still going. It's been probably closer to a year, which is normal. Make sense? Okay, just touching the glass portion of a halogen lamp with bare skin will cause the lamp to fail prematurely. How soon? I don't know, but this one didn't even last a month, so too soon.
Oily?
Probably, yeah, probably. Yep. And then when we get into the vacuum tube fluorescent, sometimes we even call vacuum fluorescent display. We will use some of these, generally not for like headlights or taillights or anything, but maybe for instrumentation displays on an instrument panel. It's a nice bright light, high contrast, can display various colors. Could be like bar graphs, 7-segment numerals, multi-segment. So like the clock, or on a newer, so like on an old car we had more analog mechanical gauges and needles, right? But you know, on a new car, we'll a lot of times pair this up with an LCD, like a liquid crystal display, and your tachometer won't actually be a needle, it'll be bars that jump up, right? Well, these can fail. And so if you've ever seen, let's just say, a clock, right? You ever notice how when the clock makes an 8, it has these little bars to make an 8? Then once in a while, one of the bars will wear out and it'll just never light again. That would be this type of a failure. So the LCD is liquid crystal display, but a lot of times it'll use a vacuum tube backing. And that's actually really similar to these. It's just, we don't really replace that. We don't go in this far. This is inside of the circuit. We're kind of done. So if you ever have, let's say the clock and it has one bar that's dead and it can't make 8 because that one's dead, you know, we're just going to replace the clock. We don't go in and solder different bulbs and backlighting. That's just not what we do. but actually the failure would be similar to these. Cool. So that one, not a real big deal. HIDs, we definitely need to cover in a little more detail. So they're going to produce light with an electric arc rather than a glowing filament. What? So yeah, literally, there's no filament in there. There's no filament to fail or to get hot and blow. There's no tungsten or anything. We're going to actually fill the glass bulb with, let's say, xenon gas, and then there's going to be a little, a couple terminals. There's going to be like a positive and a negative, and if we charge the positive with a high enough voltage, the electricity is going to arc to the negative. But when it arcs to the negative, it's actually going to go through the xenon gas. The xenon gas itself will emit the color, the white. The white if it's a 6K frequency. Make sense? So if you think about it, that sounds kind of more reliable, right? I mean, there's no filament to break apart. We're just literally increasing the voltage high enough to arc through the chamber and light the gas. So actually the HID bulbs are pretty reliable. They're more reliable than a halogen. They last longer. They're pretty good. Make sense? They produce more light for that same power level. So if you were to look at tungsten, even halogen, those are going to be more inefficient. The HID is going to produce more light for the same amount of watts, right? So the HID is kind of an improvement. I'd say overall the HID is a great improvement. So if you've ever seen let's say we'll go with a Nissan 350Z, fair enough. If you get the basic 350Z, it comes with halogen bulbs. If you get the nicer model, they'll call like the Xenon light upgrade. It's a lot nicer, much brighter, much lighter, and yet they don't have to run bigger wires. They don't consume more power. They just put out a better amount of light measured in lumens for the same amount of watts. Cool. However, you ready? However, the HID headlamp bulbs do not run on low voltage DC. Huh, okay, all right. They require the ballast with an internal or external igniter that's either integrated into the bulb or included as a separate unit or part in the ballast. Whoa, what the heck are we talking about there?
Is that those light bulbs that have like that whole extra battery pack behind them?
It may look like a battery pack, but that's the ballast. So in that ballast, boom, we give the ballast the 12 volts. The ballast transforms it into a higher voltage. Make sense? It's interesting because they make it a higher voltage with the lower amps, and that's some of the reason that it's more efficient actually. But we could do, I don't actually remember the number of volts, but it's high voltage. If you look on a ballast, a lot of times it'll have like a little lightning bolt signal with a hand and a no. Like, don't touch this ballast, don't try to test this ballast. You can't use your regular meter to test this ballast, right? Because that's what the ballast does. It takes the low voltage and it makes it into high voltage. And it has to, because it has to actually jump the gap inside of the bulb and ignite the xenon gas. See, that's...
What kind of cars have the HID system?
So if I were to take you back in time, and let's say we went back to like the 90s, none. Realistically, none. 2000s, the cool cars. You know, so back in the day, if you're in the tuner scene, all of a sudden the tuner scenes had these like bright white lights, and you're like, whoa, what the heck is that? That looks cool. They started doing that in a lot of the cars. High-end stuff, the German stuff had HIDs. Then if you looked into like the domestic, if you were to look at let's say a Tahoe, halogen, an Escalade, HIDs. You know, so the HIDs were more money. Same, like I said, the 350Z, the base model, halogen, the high-end model, HIDs. But then I'd say now a lot more cars have the HIDs. So even if you were to look at like a base model Corolla, a current base model Corolla is actually using LEDs, I believe. But the HIDs were for the nicer ones. It's more expensive. You're going to have to pay for the ballast. It was like I think Avalon too. Yeah. But those, you know, on a lot of them, that was like $1,000 option. So for the normal people, they're kind of like, what do I want $1,000 headlight upgrade? I don't need that. So they usually wouldn't, yeah, for the fog, but they usually wouldn't say like just the HIDs. They'd give you the whole better package. You got the leather, you got the this, you got the other thing, you got the spoiler, and the HIDs. Yeah, like the higher end sport model or whatever. But they're nice. Okay, and so, but the key is, the main thing I want you to understand with HIDs, they have to have that box. That box is the ballast. The ballast gets 12 volts. You can test for 12 volts going into the box, but after that, it becomes very difficult to tell if it's putting out the high voltage, and generally we don't. There's no way to really probe it. Because it's high voltage, they seal the connections really well. You can't back probe. If you were to back probe to test it, you just ruined the connection. You can't have it exposed because, you know, it's high voltage, so we have to basically prevent arcs from coming out. So if the ballast gets 12 volts, but per the manufacturer service manual all the time, if the ballast gets 12 volts and has ground, the ballast has everything it needs. If it's not working, you're going to do the ballast and the bulb. That's per the manufacturer. Now, if you're trying to make your own rules and do it however you want, cool. The next thing you could do is you could pull the HID bulb out, and a lot of times if there's a problem with the bulb, you can see it looks messed up. It's burnt or dark, or sometimes they just break. If the bulb looks good, I would suspect the ballast, and the majority of the time it's the ballast. But if the bulb looks bad and you wanted to leave the ballast and just do the bulb, there's nothing wrong with that, but you're operating kind of outside of like the book way, the manufacturer's service information way. The manufacturer wants test the power and ground going into the ballast, and if it's good and it still doesn't work, replace the ballast and the bulb as an assembly, both of them. Make sense, kind of? So it's still not really that hard to diagnose. Cool. And then again, you could get 28 to 3,500 lumens for just 35 to 38 watts. You know, so this is still very low watts, but you're getting a lot of lumens. So it's nice for illumination without ruining your efficiency. It's substantially greater lumens than halogens. However, ready, this is the negative, can impact negatively, so this is bad, the vision of oncoming traffic due to their high intensity. All right, so like I see this all the time on Nextdoor. I don't know if you guys use Nextdoor at all. Someday when you get a little older, you will. People complaining, mostly older people. What is with these lights? These lights are too bright. I have to wear sunglasses when I drive at night. And like, I'm kind of thinking, well, from the manufacturer, these lights are brighter, but they should be focused and aimed in a very clean way where it shouldn't hurt the driver's eyes. However, you get somebody who yanks the halogens out and they slam in HIDs and they're not aimed very well and they're not really like a projector style. And next thing you know, they can be pretty bright. I mean, there's times where like I'm driving and I'm like, this is just irritating. Like those are just too bright and those are too bright. And
Have you seen people put reflectors on the back of their seats?
Yeah, I was about to say that right now.
I've seen some stuff, yeah. I mean, like if they're behind me, a lot of times I'll just move the mirrors and just kind of be done. But that is the
People be
negative.
Flashing me like as if I have the high beams on, but
Yeah.
it's actually not even the high.
Yeah, no, and I get that too, and I've had quite a few of those. So the thing is, they're great, but other people might be upset. So if they're done from the factory though, they should be aimed just right. And if they're in the right type of housing that's made for the HID, that you'll see a clean line. Like if you project them out, you'll see a really clean line where down here is very bright white and right here will be dark. And that dark is what we want to be in the eyes of the oncoming traffic. One of the negatives I see though is like there's a couple intersections that I'll normally go through where it kind of goes up to the intersection and then on the other side of the road it kind of goes up. So like if I have a factory HID car like the Tesla or the Camaro or any of these cars that are HIDs, my car's up a little bit because it's sort of at an incline going to the intersection. So my lights are higher and then the people over here, they're sitting down and I know my headlights are right in their eyes. Like I can see them and I'm like, I'm sorry, I don't know what to do. There's nothing wrong with the car. It's just this is how the intersection is. Some of it's, you know, that's a challenge. But once I get out of the intersection and I'm going up through the canyon close to home and it's pitch black dark, I really like those HIDs because I'd be getting coyotes and bobcats and generally not deer, but all sorts of animals. And I'm like, the HIDs are nice. But for other people at the intersection, not so much. Okay, so it's really critical that we have these aimed right. If you have them aimed higher, or you just did what I said, like you just shove HIDs in a regular halogen style housing, those tend to project like this. And that's a little rough for the oncoming people. So if you are getting flashed by oncoming people, just make sure that they're aimed well, okay? Now, some countries actually mandate HIDs only installed on vehicles with lens cleaning systems and automatic self-leveling systems. Now, part of the reason for that is they do have vehicles that will level the headlights. So let's just say you have something pretty high end. Let's say it's a Rolls Royce, and you're about to take your Rolls Royce to the airport to pick up your European diplomat friends, and you put a whole bunch of European diplomat friends in the back. Would you agree that your suspension's going to kind of do this, right? Well, now where are your headlights aiming? Way too high. So they're saying, no problem, you want HIDs? You have to have automatic headlight aiming. So when you pick your fancy friends up in your fancy car and they all sit in the back and it pops a little wheelie and now you're blinding everyone, you need a system that's going to drop those down. So automatic headlight aiming systems is the thing. That's a thing. Like even like a Range Rover, you'll jump in, you go to start it, and the headlights will do this little sequence. It checks the automatic aiming system, the automatic leveling system before you start driving. Cool. But that also makes it pretty expensive. Now, motorcycles a lot of times will get a free pass because they're like, you guys get run over, me too. I got the scars to prove it if you want to see someday. But they'll be like, hey, you get run over, so we're going to let you blind everybody so that you don't get run over. That's kind of a free pass right there. But people still will flash me oncoming, be like, turn your high beams off. And I'll be like, you want the high beams? Pow, there they are, buddy. And then I'll turn them back off. And be like, oh, never mind. That wasn't high beams. I'm good. Cool, especially on one of the bikes with the big LEDs and stuff. Okay, but they are more expensive to repair, more expensive to produce, etc. This is your HID. We'll call it a bulb, but it's kind of a bulb, but this is a lot of times the igniter too. So this right here, sometimes they'll include the ballast all in this box and in an assembly. So we might have just 12 volts come into this box. This box boosts it up to the high voltage, and it has the igniter, and it has the bulb loosely. So if you look, there's a little wire that comes in here and a little wire that comes in here, and these are going to ignite the xenon gas. So this is a whole assembly. These are fairly nice because they're self-contained. However, they're not always in assembly. Sometimes they'll just be the igniter and bulb, if you will. So there'd be this part, then there'd be a wire down here, and that would go to a ballast, and the ballast is kind of separate. So it really depends on the type. So they're nice, but more expensive. That one, I actually don't recall if that one I don't think that is the ballast, actually. I think this is just the igniter. So if this part was bad, no problem, but if you actually needed the ballast, that's another several $100s. Then here's a difference between halogen and HID. You can just see, just much more light. It's a nice system. Cool. Then again, if it's an HID, they may need to have potentially 25,000 volts. So you're thinking like 25,000 volts. Now you understand why you can't handle these in the same way as your typical incandescent or halogen. 25,000 volts absolutely is enough to spark a spark plug and spark you and make you lose your hair if you do it too many times. Okay, that's what happens. And then again, the transformer, that's really the ballast. So the ballast is a transformer. It takes low voltage into high voltage. When you're working on this, safety glasses, high voltage safety gloves, safety boots should be worn. I'm good with that, but I'd say this is a little overkill. You know what I'm gonna do if I'm gonna work on this? I'm gonna turn it off. I'm gonna make sure it stays off, and once it's off, then I'll do all this work. I'm not gonna wear high voltage safety gloves for working on HIDs. I will wear safety glasses because I have to do that. So like, don't be really afraid of these. It's not like working on a hybrid vehicle where it can do a high voltage and high amps. These HIDs are high voltage. Yes, it'll shock you. No, it's not going to kill you. Okay, but turn it off. You want to know the reason that they'll say this by the book though? Why do you think? Let's say you're out there testing it and the customer says, oh, I forgot my iPad in the car. I forgot my iPad. Can I go out to the car? There you are under the hood working on it. And the service advisor or whatever brings the customer out and says, oh yeah, go ahead and get that. You know, sometimes when you open the door or power the key on, you know, the headlights will light up. So they may say, oh yeah, I need to get it, but let me power it on so I can put the window down. Next thing you know, the lights are on. If you're testing it, that will absolutely shock you. It'll be shocking to you to test that. Okay. And then again, it should be dry. Don't touch the ballast while it's operating. Person with like electronic implants such as pacemaker or whatever, that could be a problem. Okay, so you know, if you have a pacemaker, an HID shock could actually mess the pacemaker up. Okay, so now you all know. All right. And then the other thing is they actually produce UV light. So when it's in the housing, it's fine. It's all made for UV protection. But when you have it out, you actually wouldn't want to walk around with an HID. It's producing UV light. You know, that could be like hurt your eyes. It's kind of like sunburn too. Hurt your eyes, hurt your skin, etc. Give you skin cancer, but that'd be long-term exposure. So while I agree, it's sort of like if it's on for a second, you don't have cancer. But if you're doing it all the time, it's on and you're exposed, yeah, you don't want to do that. Although you may go in a tanning booth and give yourself skin cancer by choice. You don't want to get it from an HID. It must be maintained in a horizontal position when it's on. So that's another interesting thing. The way the bulb sits, it's actually supposed to be in that position. It's not designed to be moved all over the place. And then if we are replacing these bulbs because it has the xenon gas, those are actually not something you're supposed to throw in the basic trash. That's hazmat, hazardous materials. So if you're at work, you'd say, hey, what should I do with these HID bulbs that are no good? And they'll be like, just throw them in the trash, probably. But that's breaking the rules. Okay? Now, one of my more fun things, LEDs, light emitting diodes. So they've been used for quite a while, but they've been gaining in popularity, a lot of popularity. It's possible to get the LEDs that emit bright red, green, blue, yellow, clear, white light. A lot of times used for brake lights, turn signals, interior lights. The cool thing is they turn on instantly. So you didn't see this on HIDs. You know why? It actually takes HIDs a small amount of time to warm up. They got to start to ignite that gas, and then they're going to slowly get to their brightness level. LEDs, you hit the switch and boom, they're full intensity right away. Cool, so that's another positive. They're really good for visibility. They run cooler than HIDs. They consume less energy. They're much smaller. They can last up to 100 times longer. So there's a lot of positives and positives and positives of LEDs. And again, one of the main things is they consume less energy. So that means your alternator doesn't have to work as hard. That means you're going to have less emissions, higher MPGs. Make sense? Big one. The other thing that's nice, they last up to 100 times longer. And that's true, but one of the negatives would be, like the vehicle I keep looking at, and I'm not ready to pull the trigger because the EV market's kind of sketchy, but the Hummer EV, I'm in a couple of groups of those with those owners, and somebody's in the parking lot and somebody like backed into it and broke the taillight. It's $4,000.
What?
For the taillight, partner. I'm just letting you know. Now,
More wiring probably.
I don't think it's just because it's an LED, but let me give you like an example of what I'm getting at. Let's say it's an Escalade too, the new Escalades with those big old lights. So the thing is, yes, they can last up to 100 times longer. They actually should really last, in theory, the life of the vehicle. But the thing is, the vehicle's not just sitting there working. It's going over bumps and stuff hits it in the parking lot and whatever. These are expensive. So if you look at those Hummer EV taillights or the Escalade, it's a whole big assembly, and it's plastic, and it's got this color and that color and multiple pieces, and then it's got a printed circuit board inside and LED chip after chip after chip after chip after chip.
What?
Illuminated.
Print?
Printed circuit board. So like let's say let's say you wanted a really cool looking LED. I'll
Oh, like
buy.
pattern. You're talking about.
Yeah, they do the cool patterns and all that type of stuff.
Okay, yeah, okay.
They're cool. I like them.
Yeah, yeah.
We used to like link them boards with them LED light games back in the day. When I was younger. I know you remember.
Yeah, light bright.
Yeah, there you
Light
go.
bright. I gotcha. Look, those are going for cheap now, but I heard some people were paying some wild money. I'm not sure all what's happened since then. That one's a little more, 13, 20.
Yeah.
But when they first came out, they were even more. Let's go with a.
And those are for, those are the
Every time I look at eBay.
So the Escalades are real expensive.
Every time I look at eBay, these cars, like,
And these are all aftermarkets and stuff, right? So if we could find.
Those right there.
Yeah, there you go. I mean, you're looking at 400 something, and that's for like just some aftermarket junk.
so it's just basically the pattern they print, they put the LEDs together.
When it lights up.
They can make it really cool. I was hoping I could get it a little bit bigger, but they can make them really cool style. So if you want all these LEDs to be stacked and then you want a bar and whatever, on the backside they have to have like a computer chip, the green semiconductor material and little circuits, and each one of these is going to have multiple chips on chips and chips and
Not
circuit
only do
board
they
and whatever.
light up, they also have like a special.
They could do
like, rhythm.
sequencing.
Yeah, sequencing.
Yeah, exactly. I mean, it could be cool. You could have this one go broop, broop, or broop, broop. Yeah, pretty neat.
Yeah, the headlights have like 4 bars.
Yeah.
They actually lower every time. It like,
Uh-huh. Okay, so if I were to show you this one, like there's amazing stuff you could do with LEDs, but like for example, we'll do real quick. If this is, I don't want to get all into the details, but let's see if they start to charge this one. Okay, here's the chart, here's the turn. That was the turn, right? So there's a sequence. Here's actually charging. So if you're sitting way across the parking lot and you plug it into the EV charger, you can actually see where the charge status is. No, that's for real right there. Yeah, they're,
Is that the?
So you could be like in a diner and be like.
and you could just look across the street and be like, all right, how charged is my battery?
Yeah, those are ugly.
I'm gonna go out there and make comments about your Jeep.
I'm sorry, that's not a Hummer.
No, it's okay. So now you guys can see though, like with LEDs, you can do cool stuff, but the cooler it is, the more complex it is, the more expensive it's gonna be. Make sense? And the problem is, like if you look at this or that Hummer front one or that Escalade rear one, like you can't go in and replace an LED. It's all an assembly. It's all soldered together. It's all printed together and stuff. So
VW lights that are just like one simple bar going
yes,
across.
same. So that's further justification for why, like I picked on my dad a little. He'd pull the bulb out and he'd look at it like this and be like, hey dad, when it's an LED, you can't do that. And if you say, oh, the LED doesn't work, let's replace the LED, it could be hundreds, if not thousands. Literally thousands.
You guys changed the whole board.
Because you got to change the whole assembly right there. Like those Escalade ones, boom, the whole assembly. And you saw for aftermarket, they were for something. I probably wouldn't even sell that type of thing in the shop. I try to get a replacement for original, because if you put those aftermarket, in fact, I had one, I told you, the lady's husband backed into something and then she said, can you look at the bulb? Or can you look at the tail light? And I was like, it's all LED, what's wrong? Well, once in a while it flickers, and I'm sort of like, honestly, if the 12 volts in the ground going to it are good and it's flickering, it's inside there. There's nothing that we as technicians do inside there. You just sell a whole nother assembly. And she's sort of like, well, I just put it in, but it was an Amazon one. And I'm sort of like, honestly, I don't even want to get involved, because there's not really anything for me to do. If I verify it's getting what it needs and it still has an issue, you're going to replace the whole housing. But if that Amazon one already had an issue and it's brand new, you're going to put another one in and stuff. So like doing these, it's just different. So if this doesn't work, we can't take it out and look at it. We can't, just simply swap an LED out. It's the whole assembly, and it's going to be expensive. So what we really need to get good at is making sure it's getting what it needs to work. So if it's a tail light, remember, it should have 12 volts and ground going in. If it doesn't work and it has 12 volts and it has ground, it's inside, that's it. You sell it, it's done. However, what if it doesn't have 12 volts on the wire? Should we sell the LED assembly? It doesn't have 12 volts on the wire. No, we got to figure out why it doesn't have 12 volts on the wire, right? So it's just further support for why you really need to be able to diagnose it with voltage and resistance rather than just looking at it. Because looking at it doesn't get you anything anymore. Cool. But they're great. All those cool things, brake lights and turn signals and all that type of stuff. And I really do like the LEDs. They can do some cool stuff. However, here's a retrofit. So if you wanted to pull out an incandescent and put in an LED, you can. But remember, LED is light emitting diode. So you remember what a diode does with electronics? One direction. Okay, so if we were to take this LED, pull this incandescent out. An incandescent you can put either way, right? The resistance is the same one way as another. With some of these LEDs, it can go this way, but it can't go that way. A lot of times it's polarity specific. It's not reversible, yeah. Now sometimes, well, it's been actually pretty common. I've seen a lot of people do like a full LED retrofit and they won't test them. They'll just pull the bumper off and plug all of them in and they'll start up and they'll be like, man, half of these LEDs don't work. This Chinese eBay junk. Well, 50% of them don't work because 50% of them are in backwards. So you could, yeah, you can. Then you're gonna cut some wires and stuff. So the better thing is just to flip it around. But that means you're taking it all back apart, all right? So now everybody's in the clear. If you retrofit to an LED, a lot of times you have to have it in the correct orientation. You can't have it backwards. It's a diode. It only works one direction.
And you can't even flip it. You just have to turn the whole thing around.
Yeah, you just literally have to just reinstall the bulb. You take it out, turn it, reinstall it the other way. Because see, there's one contact here and one here. This one needs to be positive, this one needs to be negative. But if you had it flipped, this one's negative and this one's positive, it won't flow that direction with the diode.
Possibly blow the bulb as well.
Not really, no. It doesn't hurt it, but it just doesn't work. You know, so, but then they do make some that are nicer, that they basically do double LEDs, one for this way and one for that way. That way, if you do install it, it'll work no matter what. But those are more expensive and kind of unnecessary. But hey, I don't know what's going on out there. But those ones, you can retrofit. There's a couple challenges I'd like to point out though. If it's a turn signal, you know, the way your turn signals work, they're expecting a certain amount of current flow. If you change the incandescent to an LED, your current flow is going to be much less because this has a lot more resistance. Remember, these are more efficient. They use a lot less watts. So your current flow is going to go down. It can make your turn signal, rather than this, it can go like this. You ever seen that? Hyper flashing or fast flashing. It's just like if you have a bulb out. So if you put in an LED for a turn signal, sometimes you have to add a resistor in line, or you can change the flasher to be like a heavy duty flasher or an electronic flasher that'll make it flash the correct speed. You know, so if it's tail lights, cool, brake lights, cool, license plate lights, cool, that's all easy. But if it's turn signals, it can cause an issue with the flash rate. Sometimes they even call it like a flash rate controller. There's ways around that, but you have to install other stuff in addition to the LED bulb. Okay, cool. And then the other thing is, like, these aren't really happy with your voltage being all over the place. Remember, they're electronics. So it's like a computer. You want a surge protector for your computer because they don't like voltage spikes. So these are good, but if you have something like an old motorcycle where the voltage is kind of rough and sloppy, it's not regulated, it's not like a computer controlled alternator, they may not last as long or work as well. Okay, and then a little bit more on just bulbs in general. A lot of times they have letters and numbers. So if you had, for example, a headlight that was an H4 and you wanted a new headlight bulb, how would you obtain one? You could just search, like, let's say 2024 Tacoma headlight bulb, but sometimes they have different options. So one of the better ways is to actually get the number off the bulb and then be like, oh, this is an H4. Let me get an H4 replacement type of thing. So those numbers mean stuff. They have like 2137s, or they have The license plate lights, we used to call them peanut bulbs, but those are usually like 194 bulbs. So sometimes working in the shop, you get this lingo. You wouldn't be like, oh, I need a license plate bulb for that, let's say like a Ford Explorer. You'd be like, I need a 194 bulb. And I'd be like, oh yeah, I got one. Here's my 194 bulb, boom. So we do know some of these numbers and letters, but not all the time. Cool, so this is a really good shot of the dual filament. I don't know which one's which, but let's just say maybe this one's for the tail lamp and it's kind of dim, and this one's for the brake lamp and it's kind of bright, right? So different filaments. Those will also have 4 connections on the bottom. So when you connect it to the socket, it's not just making a positive and negative. There's a positive and a negative for the tail light, and there's another positive and negative for the brake light when it's more bright. So there's a little more connections down in there. So I'd say overall pretty good. Different wattage on the filaments. Oh, and sometimes headlights can be dual filaments. Why do you think headlights would be dual filaments? Low beam, high beam, sometimes too. A lot of times on the newer cars, the low beams are here and the high beams are in the middle. But on older cars, there was one lamp and it'd be high beam filament or low beam filament in the same lamp. They do vary. Cool, kind of fun ones. Here, for example, they have a lot of different connections. So sometimes they'll call like bayonet, or they'll have different designs. But if you look right here, this little conductor right here, that's where the positive is. And this part out here is where the negative is. Just so you know, if you ever work on a bulb and this is all corroded and the socket's all corroded, it's not just to hold the bulb, it provides a ground on the outside of this style bulb. So be aware of that. Okay, and then these little tabs, these are just to lock it in. Okay, so they're kind of different styles. This one requires you to turn a little bit counterclockwise to free these the little studs up, and then it'll pull out. This is a wedge style. So if you look, you can see the connections there. So maybe this is your positive and this is your negative. But if you notice, if you flip it, you could use it either way. But if you were to pull, this is a 194 bulb actually. If you were to pull this out and put an LED in, you'd have to keep track of which one's positive and negative, or just try it and flip it. See, so that's where the connection's made. These connections are made in the socket. The socket's a thing you really have to inspect. So if the bulb doesn't work, you ever seen a bulb that doesn't work and you like touch it and it starts to work? It could be a problem in the socket. So like if this is the male, it could be in the female socket. Or sometimes the filament's just hanging by a thread and it's broken just by this much, and then you wiggle it and it touches, So wiggling it can give you an idea if it's the filament or the socket. If you wiggle the bulb and it changes, it's probably not way over here on the wire or this other connector way down there or the switch or anything, right? So you can use some common sense there. And then festoon style. So these are the ones like in a dome lamp. They pop up like this and the connections are made right here. Different style. Kind of depends on what the use is. And they're all designed for specific role. So it depends on what their location is. Depends on the color you want. Depends on the brightness. And in some cases actually depends on where the vehicle is. So like sometimes Europe has different style taillights than us. They might not use red. They might have amber, or the other way around, right? So the way that the vehicle is designed, it's important you guys understand that's not really our job. So when they engineer and design the vehicle, it's to meet all these government standards and regulations. So if you decide you want to take out all your red and amber side markers and put in blue ones because it's cool, no problem. But when you get a ticket, don't be surprised. It wasn't approved for those colors. These colors are actually specifically approved, or it's specifically designed to meet the regulation and the law. Make sense? Cool. And a lot of times these low intensity or low wattage bulbs are used to mark the outline or the width of the vehicle. So if you look at a car, you ever notice a lot of times there's like an orange light. If you're looking at the front, there's an orange light over here and there's an orange light over here. That's designed to basically side markers. Exactly. Side markers mark the sides. That's exactly what they do. Fun fact, did you know, like you ever seen a Raptor, Ford Raptor? You ever notice they have 3 lights in the middle of the windshield? They are wider and they fall into a different regulation, and they need to have 3 lights in the middle of the windshield like a tractor trailer because they're so wide. Literally. So those are designed to meet the law and the regulations. But a lot of times we will have some sort of lighting to highlight the perimeter of the vehicle. So if you walk down the side of the car and those corners are not illuminated, that's probably going to be like a side marker. Yeah.
It's so dangerous, like when you're driving at night and you see a car from a distance.
And you're not sure.
You're thinking it's a motorcycle. And
Yeah.
you're like, whoa.
Yeah, like, is the car here or is it here? And yeah, so all that stuff is, designed to make it safer on the roadway. So I'd be real hesitant to go ahead and change all that type of stuff. It was made for a reason to be that way. Okay, and then park and tail lights generally installed near the corners. Park lamps are placed in the front. So if we were to just highlight some of these, you ever notice you get in the vehicle, if you turn the switch one time, some lights come on? Those are your parking lights. So if you're trying to park, or if you're on the curb parked, but not necessarily needing your headlights, those are your park lights. The park lights make it so that people can see you, but you can't necessarily see them because your headlights aren't on, but that's your park lamps. The park lamps should include the tail lights, the front corner lights, all the side marker lights, the license plate lights, those should all be on. Okay, that's the first step. Like when you want to test park lamps, you just turn that. You don't necessarily need to go all the way for the headlights if you're just trying to test your marker, your side markers, and your corner lights and stuff. Okay, so boom, park lights. Then the next step on the switch, if you go a little further, that actually turns the headlights on. You can't have the headlights on without the park lights on. Make sense? As soon as you turn the switch, it's park lights, headlights. Make sense? Now, I'm curious, because I notice things. Who's ever seen a car going down the road that appears to have the headlights on, but no side marker lights, no tail lights, no license plate lights, none of that type of stuff? That for some reason, there's some things that set me off, and that's one. Now, what do you think is wrong with that car?
They just have their fog lights on.
Or a lot of times what they'll do, they'll have like running light. It could be a failure on the car, but I'm gonna say most of the time, I bet you, if you jump in and you fire the car up and you start it, a lot of times it'll turn on your headlights, but those are really like running lights. So they've made their headlights into running lights. When you're running and driving, we want the headlights on. Why do you think? Even if it's during the day. Why do you think?
It helps you respond it.
Better visibility so that people don't pull out in front of you, so that people know you're coming, right? It's all for safety, and it actually lowers your insurance rate. So if you ever call insurance and you're like, hey, I'm gonna want to get an insurance quote. Does your vehicle have daytime running lamps? Oh yeah, it does. They're not gonna verify. You tell them, oh yeah, it does. And they'll be like, good, you get a discount. You get a discount. The daytime running lights might be you turning them on during the daytime, and you're gonna get your discount, right? So they made the vehicle so that if you start it, and sometimes you have to put it in drive, but other times you just start it, it turns those lights on for visibility. Now this is what happens. People aren't familiar with their vehicles. They get in, the instrument panel lights up and the headlights are on, so they think they're good. And they're in the freeway, and I'm barreling down from Orange County one of these days during the week, and I'm sort of like, is there a car there? I don't know, is that a car? And then I'm like, oh, that is a car. No tail lights, no license plate lights, no side marker lights, but I get around the front of them. I can see passing, their instrument panels lit up, and their front headlights are on. I'm just thinking, they don't know. They just have their running lamps on. You have to actually turn the switch on to get the side markers, to get all that type of stuff, right? If it were me and I was in law enforcement, I would probably pull them over and just say, hey, just so you know, you're driving every day, every night that you drive this car, how you're doing it now, no one knows if you're there. You got no taillights, you got no nothing. I'm kind of curious if the police realize it's not most likely an error of the vehicle, it's an operator error. I'd pull them over and be like, hey, turn your headlights on. They say they are, and I'd say, no, actually turn them on. And then when I see the side markers and the taillights and everything come on, they'll say, no, now your lights are on. When you drive, you have to turn those on all the way. Make sense? 'Cause they're very different. I would just give them a coaching, right? Because they're sworn to protect and serve, right? So that would be to protect and to serve. So I would go.
I gotta meet my quota.
Oh, I'm just gonna walk away from that. No comment. All right. If it were me, though, if I were a politician, I am definitely not a politician, okay? But if I were a politician, I would have said for all the manufacturers who want those headlights to come on for better drivability, for better visibility during daytime driving, absolutely not. Have all the lights on or none of the lights on. I would have totally avoided this because I see like in a year, I'll probably see at least 100 cars like that. I'll come up on them, I'll be like, oh, there they go. They don't have their lights on. See, I would have blocked that like at a politician level, and said, for the safety of the road, it doesn't make sense for it to be daytime, for it to be nighttime, and have the car only put on the driving lights. If you're going to put on those lights and light up the instrument panel, as far as the customer knows, all the lights are on. They don't know. The instrument panel's on and the headlights are on. They can't really see their own side markers. I'd have said, no, you're asking for trouble.
My favorite thing
All of them are
about
nothing.
having daytime running lights is you gotta turn them on.
True, so you know that that's how it used to be, right? Back in the day it used to be. Now we get into a whole separate type of thing. If we branch off of this and we get into a more modern vehicle, you ever seen the auto setting? Auto setting's great. The auto setting is going to use an ambient light sensor. If it's dark out, it's going to turn them all on. If it's light out, it might have none of them on or only the running lights, but we need the input from that sensor to determine what lights should be on. So the auto are actually probably my personal favorite. All right, but I got a lot to say about that subject, so I'm gonna move on. But now you guys understand kind of where I'm at. If you look at the car and these lights are on, but none of these lights are on, those are probably running lamps, right? If just that one, or maybe just that one, but not this one, this one, this one, this one, I don't think that you have a blown left tail light bulb, right tail light bulb, right side marker, right parking lamp, all the way in the car, all those lights out at one time. I don't think so. I just don't think the switch is in the right position. But there you go, it shows a pretty good one. Your parking lamps shouldn't really highlight the edge of the vehicle, but it should make it so you could see the front. And then technically over here, that's a side marker. That's gonna show you the side. Of course, license plate lights are critical. And then when we look at this term, the bulbs are connected in parallel with each other. So what that means is we're gonna send one wire out for your park lamps from the switch. And then it's gonna go to the park lamp over here, to the park lamp over here, to the side marker lamp here, to the side marker lamp there, right? Those are all in parallel. It starts off one wire and then all the loads are in parallel. Does that make sense? So if one of those side markers doesn't work, you should already kind of know, well, like, it's not the switch. If the switch was no good, what would happen? If we had a no good switch, would it cause one of the side markers not to work?
Yeah.
I don't.
The fuse would do that.
It would cause, if it's a bad switch or a bad fuse for the parking lights, none of them will work. Exactly. So if you roll up to the car and you see the parking lights work except for one, you're really only worried about that part of the circuit. Because remember, it's a parallel. That part's in parallel. Go ahead.
Well, I know that certain, like if one blows out, all of them go out.
I haven't, that's generally not, there's something going on there. If one park lamp fails and then all of a sudden all the other ones fail, maybe there is something else going on, but no, that one doesn't compute. No, something sounds weird there. Something funky there for sure. Right, and then remember, computer controlled stuff is coming in pretty strong. That means the driver no longer really has to do much of anything. If it's computer controlled, the computer turns on the headlights, the park lamps, all that type of stuff. And it's probably going to use that ambient light sensor in the dash. And if it's dark outside, they're just going to turn them on. And if it's daylight outside, they may turn on just the running lights. Personally, I would turn them all on, but they're trying to save a little bit of gas and a little lower fuel economy and a little lower emissions by only running the running lights, not the license plate lights and park lights. So kind of funny. Cool. So here's a fun one. If you look at front rear, generally, if you're looking from the front of the vehicle at the front, it's probably going to be amber lighting. Make sense? If you're at the back of the vehicle looking at the back, it's probably going to be red. Why do you think? You want to know if that car's coming at you or going the same direction, right? So that's how this is designed to be. So if you see orange lights, that means it's coming at you. And if you see red lights, that means it's going away. That's why when you see somebody say like, oh, I'm going to put red side markers in. Wait a minute, not in the front, because now it looks like you're going the same direction whereas you're oncoming, right? So this is all DOT. This is all DOT, Department of Transportation sets all this stuff. That's why just in the mirror, the front side of the mirror amber, the glass side of the mirror red for a turn signal.
So those are considered the marker lights now, huh?
Yeah, sometimes they're both, sometimes they're turn signals. So the marker lights used to be as simple as the side markers, but then they're like, well, let's put them on the mirrors, let's put them here, let's put them there. So it's kind of, a lot of times DOT will set the minimums, and then if you want to add lights on the mirror, great, you can do that. But if it's facing rearward, it better be red. If it's facing forward, it better be amber. Kind of makes sense. So there's some logic there. Now here's a fun one. When we look at brake lights, we got this thing, the chimsel. What the heck's the chimsel? Yeah, interesting.
Hit that light all the way across.
Yeah, look at this. A center, see, high mount stop light. Center high mount stop lamp or stop light. What the heck does that mean? The one in the middle?
Forward sign right
The one in the middle, yeah. Old cars didn't though. That's what was interesting. If you came up on an old car, it was kind of hard to tell if it was brake lights or tail lights. Whereas now, if it's tail lights, this is out. And if it's brake lights, yeah, these are brighter, but also it's very apparent because this is lit. See what I'm saying? So they made this a requirement. It's more to like get the person who's about to rear end you because they've been drinking too many adult beverages. Because it's Modelo time, you know, this type of thing. They're gonna be like, oh, there's a light there, let me stop, and not boom, you know. Yep, so something like that. That's your center high mounted stop lamp. And a lot of times this might have its own fuse, and in the fuse box it may say chimsel, and you'd be like, the chimsel. Well, there you go. Sometimes it's in the wing. Sometimes it's above the glass, like in a truck, in a pickup truck. They don't put them in the tailgate.
Oh, right on the back.
Yeah, right in the cab. Sometimes it's on the deck lid or the trunk. And then sometimes what other people will do is they'll put like a little smart module in there and they'll make this thing flash. And actually, from what I recall, I believe that's legal. So if you are worried about getting rear-ended and you put a little module in there, every time you hit the brakes, it'll make this thing flash like 3 times just to really make sure the person behind you who's sending that text message stops for a second and doesn't run you over. Okay, cool. Now, if we were to look at the diagram, because this is where we kind of need to go, if you press the brake pedal, what your brake pedal actually does is electrically closes this switch. When you release the brake pedal, it electrically opens the switch. So if we had an open switch, look, 12 volts from the battery through the fuse, fusible link, fuse, whatever, goes to the switch and it waits there until you press the brake switch. When you press the brake switch, it closes it, so what happens? 12 volt goes through and goes to this point. This is where it's really parallel. It splits off and it gives 12 volts to this bulb and 12 volts to that bulb. So if this bulb was no good, this bulb would still get 12 volts, so it still works, right? Because it's a parallel circuit. So diagnosing brake lamps is actually really that simple. If you have 3 brake lights, right? The left, the right, and the center, and none of them work, what do you suspect? You think you got 3 blown bulbs? Because you could. But true, it could be the fuse, right? It could be the switch. It could even be this wire or this connector. But if it's all 3 of them, I don't think it's going to be 3 bulbs. Maybe if it is 3 bulbs, it's probably because one blew last year and one blew this year and one just blew this week, and the people just have no inspections done and nobody ever looks at the car. That's possible, but not likely though. So kind of when we look at this, you know, use your brain and be like, well, is it more likely that 3 bulbs blew or 1 switch is bad? Probably the 1 switch. Make sense?
Can I just get this little part right?
Shoot it. Oh, and the other thing is, actually, I need to stay on the slide. This is old school mechanical. Now it's slightly different. Now this switch is more of an input to the body control module, and the body control module will light up all these brake lights. So if the switch was bad, it wouldn't give the signal to the BCM, it wouldn't light the lights. Now let's go way back. Remember how we tested switches back in the day? We used the meter, we could use the Tesla, whatever. But what other tool did we use that has to do with that body control module? Body control. How did we test switches that were computerized? Come on, Mason. The Game Boy?
The scanner.
Yeah, exactly. If you wanted to test this switch on a computer-controlled circuit, I find it even easier. I don't even need to crawl up under there. I go in the scan tool, go to the body control module, look at the brake light, switch, and it says applied or released. I apply it, what should it say? Applied. I release it, what should it say? Released. And so that's how we test the switches on a computer-controlled, this more scan tool. It's kind of more what we cover in electrical too, FYI, but so you know. Here's some reverse lights. Now, anybody know what this vehicle is? Close. Yeah. Yeah, and I think it's a Trans Am because it says WS6. So that right there is a unit right there. That's a unit. Like a O2. O2 is the final year they made it. Uh-huh. All right, but these are their backup lights, the reverse lamps. What do you think they're for?
Reverse.
Yeah, they're for reverse, but provide the driver with vision behind the vehicle at night so that they can back up and see. But also, if you're walking through Costco parking lot and you see white lights in the back of a car, you know what's about to happen, don't you?
They're backing up.
Move! They're gonna run you over. Makes sense? So like, I'm really always plugged in. I'm always looking. And if I see reverse lights, I'm like, oop, we're gonna go this way. And my wife's kind of like, doo-doo-doo-doo. And I'm like, no, look at those white lights. They're in reverse. Back it up. You know, so it actually is helpful to you if you think about these types of things. You see those white lights on, you better move. Okay, so it's for both. It's for both. If they really wanted to make it safe, let's say this was a hybrid or electric vehicle. You know, when the hybrid or EV gets put in reverse, let's say like a Prius, you ever notice anything? Because
Go too far, that thing it locks up.
True, but like if you're walking and let's just say you're not even looking, let's say your eyes are closed, they make sounds. So on these cars, they expected you to be able to hear it and know it's moving, but further you can see it with the white lights and be like, oh, it's moving. But see, if it's a hybrid or EV, it could be about to move, but you don't hear the engine. And so that's why some of the mandates have been, it has to make some sort of noise when it's ready to move. So if you hear a ooh or zzz, or it's like some of the Hyundais are more like, can't make the sound, but they're like, trong, wong, wong, and you're like, what the heck? They're about to move, and if you see the white lights on, get out of the way. Cool? And you guys know, yes, it's illegal to have any of these lights not working. And now hopefully it's clear to you why. All these lights are here for a purpose. If you have a dome light, that's not illegal. If you have a dome light that's an op, you can't get pulled over for that. But if you have any of these exterior lamps, you can get pulled over for that because as the law is written, you need these side markers, you need 2 tail lights, you need 3 brake lights, including the center high mount stop lamp, you need white reverse lights that face the back. You need all these things as defined by DOT. So the police officers don't make the laws, they just enforce the law. So if you do get pulled over, that's why. One of the other things is, if you think about it, if it's in reverse, what color is this light?
White.
All right, so what if you have a tail light that's broken and there's white light coming through the tail light? What's that mean? Are you in reverse? No, it's just broken. So see, that's why the ticket's legit. The only white light shining out the back should be indicating reverse. So if you're rolling down the freeway and you see white light coming at you, you're like either A, they're in reverse, or B, they're oncoming, time to panic. But in the meantime, it's just because somebody broke their tail light. Makes sense? So that's why it's a legit ticket. You know, it might not be a nice encounter, but that's why the law is the law, because these are not supposed to be appearing unless you're in reverse. Okay, makes sense? And then turn signals, I think you guys kind of know. So this is just to indicate, well, actually, you might not know, Californian people. When you're going to turn, there's this little thing right here. You got to tell this to all your BMW friends. If you're going to go left, you do this, click, and then it goes like this. And then people know where you're trying to go. And then they're like, oh, let me make room. Let me make sure you don't hit me. Or they're like, oh, let me block you so you can't change lanes. Now, I get that. I really get that. But I'm just saying, and I know, and I understand. But as somebody who does hundreds of thousands of miles in motorcycle miles, if I see a turn signal, I commit to all of you. If I see this turn signal and I'm here, I promise you, I'm going to make as much room as I can. I'm going to get out of the way. You win. I lose with the help of your 4,000-pound cage. I know that I lose. I have already lost that several times. So turn signals are very helpful. Obviously, some of that's a joke. It's honest. I'm trying to be silly. But that's the only reason it's there. It's to indicate that you're turning left. So this, by law, can actually be red or amber. It could be either one. Some of them are just red. It'll light the whole tail light. But in the front, it needs to be the amber color. The front's amber. The rear could be amber or red. They do seem like they're going more to the amber lately, but it's not always the case, especially like with trucks, because you'll just have one solid taillight back there that doesn't necessarily have amber in it, so they'll make the whole red one glow. Either ones, those are legit. Okay, so it should be good. And then of course inside, that's where we have the switch, and inside that's where we have the little green arrow to indicate that it's still on after you forgot that it was on. And then hopefully it's going tick, 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 and you're like, oh, I need to turn that off. Because then other people are like, hey, they're turning, let me make room. And here you are, and they're waving like, come on over. Come on, there's room. And you're, and then you're like, oh, forget it. They're sleeping. And you pass them.
Honking and flipping you off.
Yeah.
You get mad.
Roar. Okay, and then we talk a lot about the timer circuit, but again, remember 60 to 120 times per minute. So if it's 60, that's about once a second, right? So if you look at a turn signal, it's going 1 Mississippi, 1 Mississippi, 1 Mississippi, that's good. If it's going wah, 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 something's wrong there. It might be because the bulb is blown. That's the most common.
So if it's blown, it'll click faster?
Yes.
That's crazy.
Yep. And that's just the way it is. And if we were to look at the diagram, it kind of makes sense. But when the voltage leaves the fuse box, it goes through a flasher. The flasher is going to, old school flashers would do this. They'd make contact and it'd get hot and then they'd break contact. When you have a blown bulb, it's going to decrease the amperage flow of the overall circuit, and it's going to heat and cool faster. It's going to make it go faster. So that's a good indication that you have a turn signal not working. Which one? I don't know. If it's the left one flashing fast, it's either the left front or the left rear. You got to actually get out and check. Makes sense. So if it's fast flashing, there's a good indication of light's out.
But it'd only be that one light, right? Or
Generally, it probably just, if what's interesting though, the flasher works for the left and the right. So let's say the flasher failed. You get no flashing on either side at any time. You'd put your left turn signal on and it might light up. And then you put your right turn signal on and the right side will light up, but it wouldn't provide the flash. The on and off comes from the flasher. The flasher was this mechanical bimetallic spring that would heat up and cool, but now the flasher is electronic. It's really built into the control module, or sometimes it's like its own little device. And that just literally says, all right, every 1 second I go from on to off and on to off. Every 60 seconds I do it 60 times or 120 times. Cool. So that's kind of what it's saying is on a lot of the computer controlled circuits as well, they'll have a chime go off to say, hey, you forgot your turn signal on, or they'll even, it's interesting because when it's BCM controlled and the bulb blows, there's no mechanical flasher heating and cooling. So actually there's no reason for it to flash fast, but the engineers programmed it to flash fast manually to alert the driver that they have a light out, just to help them out. It doesn't actually do that naturally anymore. They make it do that to remind them. Kind of like, it reminds me of a Ford Focus for some reason. You know the old cars, when you put the turn signal on, you'd actually hear the ding, ting, ting, ting. You could hear the flasher.
I actually like to hear that.
Me too. Most people do. But
Because there's some cars that are actually really quiet.
yeah, exactly. So if we've gone to electronic control, there is no more sound. The sound used to literally be the bimetallic spring touching and not touching. On a computer-controlled car, that noise is gone. So sometimes what they'll do, they'll put a little speaker and the computer will manually activate the speaker to fake the noise. But other cars, not so much. And like for some reason, the Ford is just the one that comes to mind. That thing's like, tock, 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 tock. It's loud. Like the little fake clicking noise is like too loud for me. And some of them are too quiet. But the Ford ones are really loud. And then once in a while, like after 30 seconds, it'll go ding, ding, ding. And you'll be like, what? Oh, my turn signal's on. So it's kind of cool when it's computer controlled. We can add some of those details there.
You know how like it's you put your signal light on and you're going through like a curve, or you're gonna take a right
Auto
turn,
canceling.
and then when you
Yeah.
so straighten out, it'll cancel it.
I totally get
Some
you.
cars don't have that, huh?
So
Yeah, the way when you start straightening up your steering,
Yeah.
it turns it off.
old cars did not. And then cars starting like the late 80s, 90s, 2000s, what they started doing, it's actually kind of a complex mechanism. I'm glad for the most part they're gone. But when you'd actually put the turn signal down, it would stay there, right? And then inside the actual steering column itself, it had a little lever that would come by and release it and pop it to the center once you turned it. And it was cool, it was convenient. But I'm gonna tell you, there were some issues with those back in the day. That little thing that would automatically release it would fail, and next thing you know, it'd break the turn signal mechanism. And so The mechanical aspect was convenient, but for the technicians, well, I mean, it was good for us. We made money on it, but they did fail, right? So on a newer car, what you may notice is when you put the turn signal down, you ever notice it doesn't stay down? You're not locking it down. You basically put it down and then it centers itself. But once you put it down, it's sending a signal to the BCM, and the BCM's like, hey, they want to turn left. It doesn't have to be stuck down. The BCM will make it turn left until it references your steering angle sensor electronically. And once your steering angle sensor goes past it, it'll say, hey, the customer completed the turn the signal off. There's no failure points. There's no lever and a plastic thing and a thing to break. This switch gave the input to the computer. The computer waited to see the steering wheel sensor turn to the left. And then once it did, it electronically cancels it. So they still do have that. But now you'll notice, pay attention when you get in a brand new car and you put the turn signal on, notice it probably doesn't stay down. You're not locking it down. You're just literally giving a down signal. And the computer's going to carry that down signal until it seems it's time to stop turn signal. Cool, so fun stuff. Hazard, you guys know what hazard lights are? Basically, they'll call them hazards or four-ways or whatever. It's the left turn signal and the right turn signal combined. It just flashes both. These used to have their own standalone flasher too, front and rear, left and right. They used to have their own flasher, so there'd be the turn signal flasher. All right, so sorry about that, you guys, just a little tiny review. So everybody's good on the hazard lights. You push the hazard button, it's the turn signals, but both sides at the same time. We had that whole big old discussion about how they have BCMs now that will control them if you're in an accident and etc. So the way we diagnose these will be pretty much the same as how we diagnose turn signals. Okay, then we talked a bit about the warning lamps. And so honest show of hands, who thinks they might pursue this ASE maybe after electrical too? I would, if I were you, why not? Okay, but just understanding, a lot of the study guides will have all sorts of information about this instrumentation, and I could go into so much detail right here, but it's not on the new ASE. So if you're working on an older car that has this type of gauge, there's stuff that you need to know that I'm not necessarily really going to cover. So they would have, I'll give you like a brief summary. See this needle right here? This needle is moved by a stepper motor. So the stepper motor will say like 1 count or maybe 20 counts or 40 counts or 12, so the stepper motor controls the needle. Makes sense? What do you think would happen if the stepper motor here was bad, was no good?
It wouldn't work.
The needle would point somewhere. I don't know where. It depends on exactly how it failed. Sometimes they break right here.
It goes all the way over and sits.
Sometimes. But if the needle actually moves, it's probably not the stepper motor. But if the needle doesn't move at all and it just seems to be stuck, it could be the stepper motor. So let's just say, looking at the temperature, you see 260. If you have the car sit overnight and you start it, do you think it's 260 degrees the second you start it? No. So if it instantly slams over here, I wouldn't suspect the stepper motor or the instrument panel. I'd suspect the actual sensor. If a sensor's shorted, it'll actually show full hot. If a sensor's open, it'll show full cold. So anytime you're looking at a problem with like this gauge, yes, it could be the gauge, but it could also be the sensor that's basically giving the signal to this gauge, if you think about it like that. Okay, so there's a lot of details in there that we skim over fairly lightly because they've changed the ASE a lot. Now, we're into this. This is right about where we should be. So we talked a bit about the headlights. Remember, the low beam and the high beam, a lot of times dual filaments. They need to be positioned correctly. So this is kind of what I mean by that. If you have, let's say you put your bulb in, but your bulb isn't sitting just right in the housing, like the headlight housing, the plastic piece. If your bulb is kind of angled, what do you think it might do? Think it's going to shine in the right location if the bulb is not sitting in the housing correctly?
It's not going to illuminate right.
Exactly. So it could be, if you have a vehicle that has a headlight concern, like the headlights are too high or low, the first thing I check is to see if the bulb's actually sitting in the housing right. I've seen many times where the headlight's aimed up too high, that you go and you do all these headlight aiming adjustments and then come to find out whoever installed the bulb was sloppy because customers install their own bulbs. entry-level technicians who are just still practicing install their own bulbs. Auto parts stores install bulbs. There's a lot of installation errors with bulbs. All right, so make sure it's sitting well. It has to be sitting just well. And then we'll get into aiming a bit later, but I think overall it should be fairly easily understood. So if you look high and low filament, and these have to be sitting just where they're supposed to be, because this reflector is going to send that light out at a certain angle. So if the bulb is sitting wrong, it's not going to be sent out at the right angle. This one, for example, is a low beam only, and it actually has like a little cone cover to prevent the light from going straight out. And again, this is on the low beam because the low beam, we really want to keep it low position-wise, but also not too bright for the oncoming people's eyes. Okay, so that's kind of the goal. Now this is something that used to be like a luxury, but now pretty much every car has it. If you ever notice, you'll especially if the car has automatic headlight feature, you'll leave it on auto, you'll start the car, the headlights will be on, you'll turn the car off, leave the headlight on the auto position, get out, the headlights are on. And they're going to stay on because it has a lot of times this timer or a delay function. Leave them on so that you can get in the house, so that you're safe, increase your safety, you can see stuff, you don't slip and trip and fall, you know, and then they'll turn themselves off. That's kind of a nice feature for that convenience aspect. But you know what that means? This type of system cannot be controlled directly by the switch, right? Because if you leave your switch in the auto position and these are staying on longer than that, how the heck are they being turned off? And the answer would be generally this is when we're into computer controlled. So as soon as we get the body control module, ultimately your switch tells the body control module you want the headlights, but the body control module itself will send the power to the relay and make the headlights come on or make the headlights stay on and then turn off after 30 seconds or 60 seconds or something, you know. So if you do have some of these issues, let's just say the customer had a Buick and they like that the lights stayed on for 60 seconds, but then they go in and they buy a new Lincoln and the lights only stay on for 30 seconds. That might actually be a customizable setting in the BCM. You may be able to increase it from 30 to 60 seconds, right? So don't go at this like I need to poke stuff with my meter. It might just be understanding the system and finding out, can I adjust some of these things in the computer? Sometimes through the menu, sometimes through the scan tool. So it's a convenience aspect. It's nice. And then similar, like with what I said, when we have these automatic lighting systems, I want you all to understand very well, you turn the headlight switch on, that'll have them turn on. You turn it off, that'll have them turn off. Or you put it on auto and then you set it and forget it. You don't look at it again. You don't have to worry about it again because the BCM will take over. The BCM will look at your switch position because it's in auto. And when it's in auto, it'll say, okay, let me look at how light it is outside. And if it's dark outside, I'll have my headlights on and my tail lights and my parking lights and all that type of stuff on. But if it's daytime outside, I might just only run the headlights just to increase visibility without necessarily using the extra energy for the tail lights and the park lights and the marker lights and all that. Right, so the automatic system is really nice. Sometimes they'll automatically dim where they'll like not go on or off, but they'll kind of like slowly dim to off. They have some different features, but the key right here, a light sensor is used to determine whether the headlamps are needed and to detect sometimes the headlamps of an oncoming vehicle. So if we have a light sensor on the dashboard, it can tell if it's day or nighttime. Assuming the customer didn't put one of those dashboard mats, you seen those? They put the dashboard mat on it. If you put the dashboard mat over the sensor, is it day or nighttime?
Night.
It's night all the time, every time, and that's all it's ever going to be, right? So be conscious. Some of these sensors are up on the dash and you can cover them up. I also had one that the customer covered up with Beanie Babies. Beanie Babies. That's
What?
right. Beanie Babies. And it actually affected their air conditioning performance because this light sensor can also be an input to your air conditioning. I'm serious.
Yeah,
They had Beanie Babies all over the place, and actually, because the Beanie Babies covered the sensor, the air conditioning system wasn't cooling at maximum because they thought it was nighttime. So the headlights were automatically on, and the AC wasn't blowing that cold because the car, as far as it knew, it was night all the time because the Beanie Babies done it. All right, and then we also will use some of these light sensors. Sometimes they'll put it like up in the mirror that'll detect oncoming headlights. Why do you think? Auto high-low beam. You got cars that can go in automatic high-low beam mode. If there's no oncoming light, high beams. If somebody's oncoming, it'll automatically see that on the sensor in the mirror, and it'll dim the lights to low beam. Sometimes it'll also sense if the lights are behind you and monochromatic mirror, dim your mirrors so that you're not blinded by the people behind you. So there's some really cool advanced features once we start to use these ambient light sensors, okay? And then a lot of times, if the sensor fails and the computer knows it fails, the default will be lights on, right? Because it's better to have the lights on than have the lights not work at all. But if it does fail, it'll set a trouble code, a DTC, a code in the ECM, BCM, PCM, whatever the system uses to control the lights. So that's a little bit more of how you do the diagnosis for the automatic. It's scan tools, it's learning the system. Driving lights, so you know, driving lights are used to supplement headlight systems. So anybody ever seen cool driving lights before? They tend to be the little LED strips, or like the Camaros had a cool one. I won't give the credit to the Mustang here, but the Camaros had like the halo and the headlights, you know. Those are like driving lights. Most of the time it's for visibility. If we were talking about, some of these lights are actually for driving, like they're not exactly fog lights, but sometimes they'll have these low facing driving lights that'll try to give you a further illumination down low. They have all sorts of different style, but these are cool driving lights. Not necessarily, they could vary. Sometimes it's for you to see better, but a lot of times you're driving. Yeah, fog lights too are slightly different, but a lot of times you're running lights.
Those are not the fog lights.
These ones, I don't think they consider fog lights. I think the fog lights would be down here.
Right.
So they consider these like just more like running lights when you're driving.
Extra lighting.
Yeah, extra lighting, supplemental lighting, if you will.
Right.
Yeah, but they could be all sorts of different styles. Sometimes they're 55 to 120 watt range. A lot of times halogen. Sometimes it's only when the high beam's working. They could really vary, right? And if you were to look, for example, at this diagram, they'll actually wire it in such a way that if the driving lights are designed to only work with the high beam, they can wire it in a way where when your low beams are on, it won't allow your auxiliary lamps, your driving lamps, to be on. So it's all on how it's engineered, right? So it kind of varies. Whatever the system is, if something's not working, you want to pull this diagram and see, like this has an aux relay, a headlight relay, a taillight relay, and the bulbs themselves. Now here's some fog lights.
Right there.
Typically fog lights would be identified. Why don't you let me bring it to you? Okay, have a seat. So fog lights are typically located lower.
Oh, yeah, I get it.
So the purpose of a fog light is just what it says. A lot of times when you have the fog, you're going to try to bring light down from the bottom, so kind of illuminate the sides, give you a little bit better view of just the road level. Now here's a fun fact. If you have fog lights factory installed on a car, do you know what happens when you hit the high beams?
They do not.
These turn off. And that's almost universal for all of them. So if you try to turn your fog lights on, a lot of times that's another switch. But then when you turn your high beams on, the fog lights will go off because it becomes a little overwhelming with fog lights and with high beams. So that's pretty common. They'll lock them out like that. Sometimes they can be yellow. I'm not exactly sure on the regulation, but I know a lot of aftermarket companies like the yellow fog lights, but I don't really see them coming like that from the factory, so I don't know. Right, and then again, if they're gonna be auto off, sometimes they'll use like multiple relays, and if your high beam relay's on, it'll cancel your fog light relay, or, in my opinion, the better setup is the BCM controls it. So if your BCM commands high beam, it is programmed to turn the fog lights off inside. So that's kind of how it would work. Okay, and there could be a lot of different types. So first one's the reflector type. That's that silver one that had kind of like the mirror around it. That's gonna shine the light, but not always real directed. It's just a reflector. But then if you have a projector style, it sort of has like a lens, and what the projector style will do, it'll take the light from the bulb, and going through the lens, it'll project it to a specific spot. Those can have like a really clean line. If you ever notice, you get in a newer car and it's like down here is bright and up here is dark, projector will do that. The projector works better. The projector style housing is better for HIDs and LEDs. Make sense? Remember, the HIDs and LEDs are brighter. We agree on that, right? So if your HIDs and LEDs are brighter and you put it in a reflector style, a lot of times you just get this light dispersion of there's just light everywhere. The cars are oncoming, they're beeping and they're flashing and they're yelling at you and they're telling you you're number one. You know that one, huh? You're number one, but I don't know, something's wrong with this finger. They use a different one. Okay, that one, that's the number one. It's probably because you took some aftermarket LEDs or HIDs and put them in a reflector style housing that was never made for that. This is made for halogen. This, however, a lot of times comes with HIDs, so this would be like super bright, but not in their eyes. Cool? Same with if you retrofit these to LED, you got to really be careful about how you're aiming them. And then the sealed beam is a little more old style. That's like the whole reflector and lamp and everything all in one. You take the big glass assembly out, you put the glass assembly in. That's a little more old school. Cool, but they're interesting. There's a halogen bulb. We're pulling the bulb out. You notice the O-ring? Why do you think the O-ring's there?
The protector. So
Yeah, we got to seal that thing. If this O-ring is gone or if that headlight's cracked and we're getting water in there, that bulb's not going to last. No chance it's going to last. Right? So we seal it up. You can see it's got the reflector behind it in red. You can see that it's got a shield a lot of times for the low beam. And then if it's a projector, it's going to have a lens that's going to actually focus it, stop the light from going up here and blinding people, and focus all of it downward. Assuming it's aimed, that's really nice. Those are the best. Cool. And then some of these can vary. Sometimes they're completely sealed. Sometimes they're semi-sealed. Sometimes they have a full shield, a partial shield, and not super. Not real critical for us, but just know there's a lot of different designs, and it's always to give the maximum visibility for the driver without impairing the oncoming cars. Okay, that's a really big deal. Makes sense? That's why I caution you against goofing around with all these different bulbs. Cool, and then HIDs we talked about a little bit. So here's your HID again, and then LEDs. So let's take a quick breakdown of these. Bright, nice, amazing. Good in the correct housing. Problematic in a basic reflector housing because it's intense and it's not focused. It might be too high. And then LEDs, kind of similar. Some LEDs are they're no improvement over your basic halogen. But other LEDs can be really bright. And the reason why is because they have low power consumption. So if you were to take out your halogen and put in an LED, it's going to use much less energy. Let's just say 10% the energy. Well, that means you could run 2 LEDs or 3 LEDs or 4 LEDs or 5. So rather than run one LED, you could run an LED that's like a super LED with 5 chipsets in it and still not have to upsize the wires or anything. So the LEDs themselves are not necessarily brighter, but because they use such low power, we can combine LED chips on chips on chips and make a lot of light after we use the combination of multiple chips. And then again, they do get warm. So sometimes we'll do heat sinks, which are like aluminum fins on the back, or other LEDs actually have fans built in. If you guys have seen some of the aftermarket LEDs, plug it in and it's got an actual fan on the back.
Yeah.
And you hear them run, and it's just cooling the LED. Those are probably pretty high powered. They're nice though. They're nice. But I want to make one point. If it's a good quality LED retrofit, a lot of times the LEDs have a little adjustment on them. So you could put them in and then shine them down the road and then do a little adjustment and get the beam down here. Get the beam out of the people's eyes. That's actually a pretty good modification. If you put them in and they're shining all up high, people are going to give you the number one finger. Cool. Now this is something you probably don't know about, but some vehicles actually have night vision. Did you know that? It's pretty big back in the day on Cadillacs. They'll actually have a night vision camera and they'll project it up on the screen or sometimes in the heads-up display just to help supplement your vision. So It's not designed to be turn off all your lights and run from the police. It's more designed to like give you even additional safety. It's of course for safety. Some are active, some are passive. So an active uses an infrared light generator that's going to project infrared light, which you don't really see. And it's going to do the front of the car and the side of the roadway. And you can't see the infrared light. That's the problem. It doesn't help you see. It doesn't blind other customers, other drivers, because we don't really see. Our eyes can't detect the frequency of these light waves. As far as you know, it's dark out there. But in reality, the night vision has already shined its own type of infrared light on all that stuff. The camera, however, can pick it up. So the camera can see what's reflected in infrared radiation, and it can basically display an image, just like, Secret Service, Special Forces night vision stuff. Like it's pretty interesting, pretty neat. But it'll put it either on the windshield, the heads-up display, or an LCD screen. It's a cool system, very cool system. Okay, and then passive, sometimes they'll actually use heat sensing camera, and that'll also be illuminated in the heads-up display or the LCD. And they can even use thermal. So part of the reason that this is included is if you're really forward-thinking and you're listening to this, our eyes are kind of limited. They're amazing, but if we want to be able to see it, it's going to affect oncoming people in a negative way, right? If you could put light bars on light bars on light bars and do Jeep stuff and be like, there you go, like full, let there be light style. And then the people oncoming, what they're like, I can't see, I'm blind, and they crash. Cool.
You also own a Jeep.
Now think about this though. If we're using these infrareds and thermal and we can detect people and we can see things without blinding other drivers, why might that be really interesting for the future cars? Do we need to see in a futuristic car?
No, the car needs to see.
The car needs to see it, and the car needs to drive itself, and we don't even need the brighter lights. We're going to have some lights so people can see the car, but the car could actually do all sorts of night vision stuff to be able to see what we can't even see at nighttime. So that's part of the reason that we beefed up on some of these. This is not ASE doesn't talk anything about thermal imaging for lighting systems at all, I promise you. But you should be aware, as the cars become more and more self-driving.
Shit, they're driving themselves out there in LA right now.
Oh yeah, they have been, for sure.
Yeah.
Right, and so this
Ubers
is,
and all that.
yeah, for sure. So, just when we're looking at headlight problems, keep in mind, we got the relay, the fuse, fusible links, the bulbs, the switch, a lot of times the BCM, computer controlled, sometimes relays. There's a lot of components, and that's why one of the next things we get into is how to do the diagnosis. So if you want to check a headlight bulb, pull it out and look, inspect. There's your headlight bulb. You can tell if it's blown generally looking at it, but if you can't, you can check for 12 volts in ground. If we're going to replace it, make sure we're wearing our gloves, right? Simple stuff. Make sure it's in the housing right. Don't touch the glass. Now, if you want to aim headlights, has anybody ever aimed headlights? In the backyard or legit? Because this is legit. You get an actual device and it'll measure the angle of the beam, and you can actually precisely adjust it in the shop.
No, brick wall.
You guys have that here?
We actually do. Yeah. We don't commonly use it, but we do have one. Now, the more old school way, you'll pull the car up to a wall or the shop door, and we make some marks. And so at 30 feet from the wall, the headlight should be about right here. And it's not real precise, but it's kind of what we're doing. So if you get a car that's in an accident, you put a new housing in there, and it might have a little bent radiator support or something, we could at least make them the same, get them approximate. But there is a specific headlight aiming tool.
Wow.
This would be a little more common in like collision in a body shop type of thing. This should really be dialed in. We're supposed to, especially if the car's in an accident and it needs to go through like salvage inspection, brake and lamp inspection. That's going to be the type of stuff that's supposed to happen. Anyway, so now you can see what that looks like. Now if you look, here's the device. You can see a little bit more. It'll show you some markings on it. Some of them are a little more computer controlled. Now if we go to aim it, if you look, it depends on the system, but a lot of times there's an adjustment. This one's a knob. Sometimes it's a screw. Sometimes you use a screwdriver. Sometimes it's a Torx or an external Torx. There's all sorts of ways, but you'll have to use something to turn it, and that'll change it to higher or lower. And they sometimes have them for left to right, but they'll always have it for higher or lower. Make sense? Because suspension changes occur. So if you have a vehicle and let's just say, as it gets older, the suspension kind of sags, and then you put some new suspension in there, or if it's a truck, right? You have a truck and you put some stuff in the bed of the truck's going to squat. Let's say that you build it for a camper, you put all your overlanding stuff in the back. Now your truck's like this permanently. So there always needs to be a mechanism to aim them. Cool. So that's one of the things that we do. And it'd be something like this, although it can't vary.
So much like a leveler.
Yeah, it's like a leveler. It allows you to re-level them. Exactly right. Cool. So if they're too dim, you can't see well. But if they're too bright, other people can't see well. So we got to kind of like have to balance a fine line there. And the other thing is, again, if you're replacing your headlights, they may be illegal, depending on, are they DOT approved, how bright they are, etc. So if you are pulled over and they say, hey, I want to inspect your headlights, that could be legitimate. And that's why as professional technicians, I wouldn't really get involved in that. We should be repairing it to original. Mods is something we'd usually let the customers take care of themselves, and so when they get the ticket, they can yell at themselves. You don't want to put in some HIDs in a janky reflector housing and blind everybody and cause an accident, get pulled over, whatever, and then be like, hey, who did this? And be like, oh, take it over to this professional technician who's certified and got a repair license. Like, not a good idea. Make sense? However, if they're dim, we can troubleshoot that. If a bulb is dim, one of the things we want to do is check the voltage. If the voltage at the bulb is supposed to be source, 12.6, and you only have 11, don't you think that's going to make it dim? If it's going to make it dim, then we need to backtrack and find, is there unwanted resistance, corrosion, etc., right? Damage to the wiring, damage to the socket, damage to these types of things. So right here, we're transitioning into available voltage drop. And that's kind of where we want to be, that's where we need to be. And it all has to do with how it affects how the light works, the intensity of the light. So here's a normal operation, right? We've got, in this case, 12.68 volts is our source voltage. Cool. So we should have 12.68 coming out of the fuse. It should go through the connector, and look, it dropped to 12.65. Is that normal?
Yes.
Yeah, it didn't drop 0.2, it dropped 0.02. So like you got charged 2 cents right there. That's I'd pay that. Okay, then it's got to go through the switch. Obviously, if you're testing the lights, you got to have the switch closed, right? So if we look at this is stop lamps, stop, and center high mounted stop lamp. If you want to test stop lamps, what do you need to do? Press the brake pedal. You got to press the brake pedal. You need to say, hey, Tony, can you get in there and press the brake pedal for me? Or get like a pry bar, or some sort of a device to hold the brake pedal. Cool. So if you see on the diagram a switch and you're trying to test these bulbs, you need to know I need to close the switch. So draw the diagram with it closed. 12.65 coming into the switch. What would you expect coming out?
12.62.
Yeah, or so. Yeah, like right around. If we were to drop that last digit, it's 12.6, 12.6, 12.6. 12.6, 12.6, right? We still have a full 12.6 coming down to the lights. Now here's the center high mount, left and right. What should they drop after going through the load? What should it have after the bulbs? Like zero-ish, right? 0.02. Like there might be some minimal amount of voltage left over because there might be some minimal amount of voltage drop occurring on the ground. But if you were to just back out a little bit, you'd be like, hey, it was 12.6 and now it's 0.0. Makes sense? You don't have to go so precise to the 62 and to the 0.02, but you can. So this is a known good right here. A good 12.6 through the switch, just a little drop to the bulbs, pretty much full voltage available. All three of these bulbs will glow bright, and then we'll have 0 volts afterwards. That's a good one. We agree? All right, so now this is stuff you already know, but we're applying it specifically to stop lamps right here. All right, so let's get a new one.
And that's a parallel circuit, right?
It's a what circuit?
Parallel circuit.
Oh, yes. So this is parallel because it's got its own access. It's got its own access. It's got its own access. All three of the loads have full access to the 12 volts. Generally in lighting, we don't deal with series because if it's series, you have a bulb here taking 6 volts and a bulb down here taking 6 volts. It just doesn't make sense. Almost everything we'll do is going to be truly a parallel circuit, but if there's a problem up here in what we would call the series portion of the circuit, if that switch was open, what would be the effect on these bulbs? No bulbs would work. But if we have one bulb not working, is it the switch? No, it'd be something maybe between here and here, or here and here, right? So that's the concept. Cool. Now, when we go to do the testing on this final exam, so you know, you guys have to consider your options. So one, we can do available voltage test. Put the black lead on the ground. Put the red lead, let's say, at the fuse, and it's in this case 12 volts at the battery, 11.9 before the load. What should it be after the load? 0-ish volts. Yeah, exactly. Right? So remember, available voltage, we stab the ground here and we poke the red in various points and we consider what it should be. Now, if it went from 11.9 to 0.0, how much did it drop? Full voltage. If it went from 11.9 to 0, if you had $11.90 here and now you have $0.0, fool, you got robbed. You lost $11.90. Make sense? So you could say in another word that the voltage drop across the load was the full 11.9. Make sense?
Yeah.
But we really measured it through available voltage. So again, available voltage coming out, yeah, we had 0.1, so you had 10 cents left over. So I guess we didn't drop 11.9, we dropped 11.8, but that'd be good. That's an acceptable drop, okay? So on this simulator, you will drag your meter lead where you want. It's up to you. You can drag them anywhere you want, but if they're not in the right spot, you're not going to be able to diagnose it. Cool, so here's a voltage drop. Remember, this is a different way to do it. On the test, you can do either one. You know why? Because in real life, you can do either one. Either one is fine, but you need to know both, because if you're trying to stretch your meter leads from the front to the back of the car, it might make more sense to do it like this. Short T-Rex arms. You're going to be like, how much drop across the bulb? How much should drop across the bulb? Do you remember? Yeah, so you put them right here. Boom. If you put them just like this and you get, oh, it's dropping 12.6, like that would be good. 12.6 drop across the bulb. The bulb should consume basically the entire drop. The entire source voltage, I should say. Cool? Now, what if you wanted to drop the switch? You do it like this. If you wanted to drop the switch, put it before the switch and after the switch. It's always measuring what's in between the leads, right? It's measuring what's in between the leads. How much should a switch drop? Like not much, right? Like definitely not more than 0.2. So this one's dropping 0.05. What's good? What's up with the switch?
Higher resistance.
Is it? Because it's only dropping 0.05. That's a small bill. So that switch is good. Okay, I got you. Part of the reason I want to give you all the time you need on this simulator is to just walk and talk these things through yourself. Do them step by step. So these are the tests. Now let's just say we did available voltage right here, okay? What would I do with my leads? You guys, you be the brain and I'll be the muscle. What should I do?
Go to the.
Start with the black one.
The ground.
Boom! What should I do with this red one?
Oh,
Check.
the top. That's 12.68.
12.6.
Yeah.
12.6. 12.6. Is the switch good if it's 12.6?
Yes.
Yeah.
Good, exactly. Would it be good if it went from 12.6 to 0?
No.
Exactly. So you're diagnosing now. Then I go to this connector and I get 12.6, and then I go down here and I get 0. So where's the open?
Right there.
On that wire, right at that connector. Boom. In the diagram, on the car, but also in the simulator, the open, you won't see the open, but you will get those measurements. 12, 12, 12, 0, 12, 0, 12, 0. Between the 12 and the 0 is where your open is.
Yeah.
Okay, like it's review a little bit. Now, if we had an open right here, what do you think that would cause on these 3 bulbs? One bulb, all bulbs?
All.
No bulbs would work because no bulbs are getting full voltage. Make sense? This, and this all
Is it an
rely on
open?
the 12. If there's an open right there, yeah.
Yeah.
But it's an open up there. Make sense? an open in the series part, it's like a freeway. If this is the main road and then it splits off 3 ways, but the accidents on the main road, none of the side streets are everything's gonna be dead. Because the main road, the only way to get to the side streets is through the highway. Nobody can get there. The open is up here where there's only 1 lane. Okay, how about this? Interesting. First off, I'm not even gonna put my meter leads on there. If you just examine this a bit for a second, I want you to think about what the customer concern would be.
One of the light bulbs not working,
How do you know?
so there's an open wire on the.
All right, I agree. So if you rolled up to this car, you would never test first. You'd always look first, right? So I want to give it to you the way that I'd see it. This bulb works. This bulb does not. This bulb does. If one of these brake light bulbs works and if 2 of the brake light bulbs work and one of them doesn't, do you think it's the brake light switch?
No.
No, thank you. So you're understanding the concept now. However, if you want to waste your time, by all means, you can do as many tests as you want on the simulator. But in the customer car, every test you do takes time. And if you want to get paid, you got to bill the customer. And you shouldn't bill the customer for tests that they don't need, right? Make sense? But let's say you're just a little cuckoo. And you're like, here we go. I need to check right here. 12.6, 12.6, 12.6. So you know why I already knew that I didn't need to do that? Because these 2 bulbs are working. If those bulbs are working, trust me, they'd be having 12.6. So I don't need to test up here. But you can if you want, by all means. Instead, I go like this. Let me go to this bulb. 12.6, 0.0, 12.6. Then I'd be like, oh, so it's not getting power to this middle bulb. I'd say 12.6 here. What about at B15? I mean, 0 here at the bulb. What about at B15? 12. 12, 0, 12, 0. This wire's open right here. Boom. You diagnosed it just like that. Right there. So that's what this simulation's. Okay, here's a new one. High resistance on the power side of the load. Okay. All right. Now what we have on this one actually is 3 dim bulbs. You can make that into like children's nursery rhyme. 3 dim bulbs. 3. Okay. 12.6. We kind of didn't totally need to do this, but we will. 12.6, 12.6, 3.5.
Oh, yeah.
Bigger symbol.
It's done already. 12.6 to 3.5. Why is this switch dropping 9.15 volts? That's way too much. That's why all 3 bulbs are dim. Would we agree? Right? So this one would be like sell the customer a switch. If we were to back up one, sell the customer a wire repair down here. If we're to back up again, sell the customer a wire repair up here, right? So it's just a matter of diagnosing correctly so that we can sell the right things. But now do you guys understand why these 3 would be dim? They're only getting 3.46 volts because this switch is hogging 9.15. Make sense? That's not an open though. What would an open be? Yeah, an open would be like 12 volts and 0 volts. The fact that it's like it's consuming 9 volts, leaving 3.5 volts is like, well, it didn't take all of it, so it's not a full-blown open. It's just taking a lot of it. That's high resistance right there.
Could just be a bunch of corrosion along the switch.
That's exactly what will happen. The switch contacts will be corroded. Another way you could test this, which is not as thorough, but another way you could double check yourself, you could disconnect the switch and check the resistance of the switch, and the resistance of a switch should be like 0.2 ohms, but you may find this switch has like 4 ohms or something, maybe 8 ohms. Cool. That's too high. And so then you sell them a switch, and then you put the switch in, you fix it, and then you're like, let me pay myself. Okay, how about this one? This one's high resistance too. And if we were to run through this, it'd be dim bulbs once again, but I'd be like, it's 12.6, 12.6, 12.6. On the ground side, I still have 10.2 volts. Why has the ground got 10.2 volts? Because the ground has high resistance down here. It shouldn't, is exactly right. So if you picture it like this, remember the allowance money? The parents are like, oh yeah, kids, you get $12.68. And the 3 kids are like, oh yeah, we all get $12.68 because they're not in series. They're in parallel. So they all have access to $12.68 a piece. By the time it gets to them, there's only 12.62. But for some reason, the 3 only get 2.42, that means some other load is consuming the 10.2 volts. And it could have been up here, but it could have been down here. And the reason you knew it was down here was because you had a full 12 volts coming in, but you had 10 volts left over. So the fact that they're leaving money left over means someone after them is consuming that 10 volts. Make sense? So you know there's an unwanted load down here, and the load in this case is corrosion on the ground. Okay, so we need to sell a wire repair here on the ground. Kind of make sense? Cool. And then a short to ground would blow the fuse. So if you turn this one on, bang, the fuse blows. You pull the fuse out. By the way, it's not on the simulator, but it's for you. You pull the fuse out, you jump in a big headlight bulb. If you plug in the headlight bulb and the bulb lights, you know what that tells you? There's 12 volts up here and there's ground down here. There should not be ground there. You know why? The load is here. So if you start at the load, before the load should be positive, after the load should be ground. If this bulb is lighting, that means there's ground in here. The only reason there'd be ground in there would be because something is shorted to ground. And look, lo and behold, this wire was pinched to the ground. That would blow the fuse. The way you'd find it, plug in the light's on, disconnect this, disconnect this, disconnect this, disconnect this, the light's still on. As soon as you disconnect this connector, actually disconnect this connector, the light's still on, disconnect this connector, the light goes off. It's between the connector that you disconnected and it didn't go off and the one you disconnected and it did go off. Make sense? Because as soon as you disconnect this connector, now the short to ground is removed from the circuit, so the light would go off, which would mean it would have no ground. Kind of weird, right? But does that make sense?
Yes.
Okay, good. Then I like it. So there's your short to ground diagnosis. This is all to get you on the car. Okay, now here's one of my favorite parts. When you get, okay, that's the concept, and you're going to do it, and you're going to do that all on your final exam, part 1. Okay? Part 2 is everything you learn over the next several days, or you can knock it out today if you want. You're going to carry that in next week for your hands-on final, which is not going to be that hard. If you wanted to check the voltage on this wire, here's how you do it. You don't stab it. You actually take a back probe and you're going to slide it right here where it can make a contact with that terminal, but not hurt it. Does that make sense? Which means if you're actually looking at your meter leads are too big. It's like if you want your toes done and you go to the nail shop and they bust out like a chainsaw. You're like, no, I don't need that. That's the wrong tool for the job, right? Your back probe on your meter lead is huge and you're going to be like, yeah, and then that's never going to work again. So the back probing is actually a device. This is good back probes. See, these are small little, like almost like pins. So we got to take the back probe, hook it up to our meter, and then just carefully slip the pin in on the blue wire right here. And that gets into the connector. So you got to know which wire you want to probe and how you're going to probe it and which terminal it's in. Makes sense? Slide it in, and then you're going to basically do exactly what you're doing in the simulation is just get your voltage readings. That's it. But these are different back probes. You can have various back probes. These are from Pico. Back probing is good. Back probing is approved. This is what I don't want you to do. They do make these tools that pierce the wire. Why do you think I don't want you to do that?
You can damage the wire.
Right, and then it's going to corrode, and it's going to have, in the future, it's going to have unwanted resistance, and you just literally made a failure. That's unethical to the customer's car. You're damaging it. Why not do this one? That's a smaller pin, right? Right in there. Okay, so this is not going to be a health class, but when you have the female terminal is expected to be a specific size. Remember, we did terminals. That's why this is like a culmination of the previous 9 units. They're expected to be a certain size, and the pin should just fit perfect, make just enough tension so it has a good connection. If I go ahead and I take this pin, which is too big, and I ram it in there, now it's damaged. What type of connection is this going to be? It's not. It's going to be an intermittent. It might flicker. It might not work at all, right? So this, if you do this in class, I'm going to kick you out of here. You go on and get. Okay, because that car, you could total a car like this. And then we got to go behind and figure out which ones got blown open. And then next thing you know, you were probing the wrong stuff with the wrong tools. Oh, like that, okay? However, sometimes, so some people will say you're not supposed to front probe. you should only back probe, right? Back probe is where we carefully go from the, like, remember back probing right here? This is actually the best picture I could find on the internet. We carefully go behind here. There's no female connection here. We're just literally contacting the metal. Back probing's great. That's going to be preferred 9 times out of 10. Once in a great while, we may need to test from the front. And actually what's happening here is only bad because the size of that pin. What if we were to have these, and these you'll notice are all different and they have part numbers. That female terminal is made to mate essentially with the male terminal. If that's the correct male terminal, that's fine. But you got to buy the kit. You got to buy this big old $300-something kit so that you can probe the front. So if you wanted to do some resistance measurement or something, front probing is cool. But here's the challenge, okay? Generally when we test it, if you want to test the light bulb, you don't want to disconnect the light bulb. You want to test it while it's working. So back probing gives you that perfect chance. But if for whatever reason you couldn't back probe because the type of terminal, whatever, they do have these, and there's actually something, I'm going to show you 2 things. I'm going to actually click this link. This will take us to AES Wave. That's a legit company. It should take us there. If not, I'll copy it and paste it. Kind of weird. Bring me to where you're supposed to be. All right, fine. We'll do copy paste. No problem. All right, so if we look at this, eventually, that's a $270 kit. This is a nice kit though. This kit's really top of the line. But if we were to look at this zoomed in, there's a detail I want to show you. All these will be the terminals that you may encounter, all the correct terminals. So you're not gonna expand the terminal, right? But what's really cool about this kit, this part's cool. Let's say it's a 4-wire connector. You can actually have multiple of these. Let's say you pulled 4 of these out. You could connect to the 4 male and to the 4 female. And if you look, these are pulled together as kind of like a Y. It's made so that, let's say you have a connector like this, right? It's made that one end will go here, and then it'll go up here to a test point, and then down here, it'll continue the circuit. So you can basically disconnect it, put in all your front probing kit, and it'll reconnect the circuit while the connector's still apart, right? And then you get yourself some nice test points up here. This is a really nice, this isn't just the back probe kit. This is a full-blown, we'll call it sometimes a breakout box. All right, so you can kind of visualize what I'm saying. Don't use any of these tools, but if you did want to check resistance, cool. But let's say it's 4 connectors and you actually want to test it while it's active, you'd have to open the connector, hook up 4 of these to re-engage the circuit without connecting the connector, and then they give you nice test points up on top. Really nice, but I can explain it in one other way. So that's a term that I want you to know. It's called breakout box, right? So say front probing. The other one I'm going to do is right here, and this will help you to understand what a breakout box is as well, which is something that's a recommended procedure for most manufacturers. So here we go. Let's click on this one. Check this out. Have you guys seen a connector like this?
Yeah.
You know what that is, right?
Yeah.
All right. So I plug it in. Boom. And then what?
For your OBD 1, 2.
But then I plug in the scan tool here. So you're like, wait a minute. This is basically like the middleman right here. So rather than me plugging my scan tool right into the OBD2 connector, I plug this one in, then I plug my scan tool in over here. So it carries all the signals through, but this is what's crazy. See all these points?
Mm-hmm.
These are the terminals. So if you want to know what's up on that terminal, you do the breakout box, and then you can easily shove your meter lead in there because it's bigger. So this is a term called the breakout box. If you had to test a lot of different points, they do have breakout boxes that have adapters where you can plug into the female end of the connector and the male end of the connector and then give yourself a test point. Cool? So when we really get on the car, pretty neat, huh? When we really get on the car, you have to have a way to be able to test the circuit without damaging the circuit. And back probing's the go-to. I admit, back probing's the go-to, but there are times where you may need something more like a breakout box. And that other kit that I was showing you, see how this one will pick up, let's say this one's terminal 1. Let's make this terminal 1 right there, okay? That terminal 1 is right there, terminal 1. Cool? So the breakout box is pre-made. The other one, if you wanted to do that, you could go to this one, and you could kind of see, right? Like if you wanted to test terminal 1, this one you'd connect to terminal 1 of the female. This other side you'd connect to terminal 1 of the male. They wouldn't hurt anything, and then your actual probe could be here, where it's a little bigger and actually fits your meter. That makes sense? So that's what I would define as safe front probing and or usage of a breakout box. Okay, cool. Any questions? You feel good? All right. Well, with that, let me have you get your final exam here. And so I'm gonna cut you guys loose.